If you're aiming for roles like data scientist, data analyst, or even data engineer, then data analytics is your first and most important step. And the best tool to get started with it is Python. In this course, we'll cover everything you need to get started with data analytics using Python, even if you're a complete beginner. We'll begin with the Python basics to get you up and running quickly. Once you're comfortable, we'll move into NumPy. Here you'll learn how to handle arrays, perform mathematical calculations, and even speed up your data analysis tasks. Next, we'll dive into Matplotlib, where you'll learn how to turn boring numbers into beautiful graphs, charts, and plots that tell a story. Then comes Seaborn, a library built on top of Matplotlib, but with even more powerful and attractive visualizations. And finally, we'll put everything together and perform a complete exploratory data analysis or EDA on a real-world dataset. This is where you learn how to clean data, analyze patterns, and extract insights, just like data professionals do in a real job. By the end of this course, you'll not only be comfortable writing Python code, but you'll also be ready to analyze data, create visuals, and draw real insights that can drive decisions. So grab your notebook, open your laptop, and let's start your journey into the world of Python and data analytics. Let's begin with the most basic concept in Python, variables. They're like a container that holds information. You can use it to store a name, a number, or even something more complex. For example, you can write name equal to John, which stores the word John as a string in the variable called name. If you write age equal to 25, the number 25 is stored as an integer. And similarly, if you write height equal to 5.4, Python understands this as a decimal or a float. What makes Python really convenient is that you don't need to tell it what kind of data you're storing. It figures that out on its own. This makes writing code much simpler and faster. Now, let's say instead of storing just one piece of data, you want to store a group of items. This is where we use something called a list. A list lets you store multiple values in a single variable. For example, if you write the information using commas inside a square bracket, you can use indexing starting from 0 to access any value. So if I write person and 0 in the brackets, I will get the output John. Similarly, person 1 will give the output 25. Lists are also mutable or changeable. That means you can update any value from the list using the indexing method. Lists are also flexible. That is, you can add new items to them or remove existing ones using simple commands like .append or .remove. Now, sometimes you might want to store multiple values like in a list, but you want to make sure that no one can change them later. That's where tuples come in. A tuple is very similar to a list, but once it's created, it cannot be modified. For instance, if you write comma separated values inside parentheses, you've created a tuple with two values, and they stay exactly the same. What this means is, if you try to change a particular value, Python will raise an error. Tuples are great for storing data that shouldn't change, like a fixed location, phone numbers, or dimensions. Moving on, let's talk about dictionaries. A dictionary in Python stores data in pairs, a key and a value, just like a real life dictionary where each word has a meaning. For example, if you write this piece of code, then name, age, and height are the keys, and their respective values are John, 25, and 5.4. You can get the value of any key simply by using its name, like person, and inside the square brackets, the key, name, which will give you John. You can also update the values or add new pairs anytime you like. Now let's take a moment to talk about loops, which are one of the most powerful features in any programming language. Loops help us repeat a task multiple times without having to write the same line of code again and again. In Python, we mainly use two types of loops, the for loop and the while loop. A for loop is useful when you know exactly how many times you want to repeat something. For example, if you want to add up the numbers from 1 to 10, you could either do it manually or you could let Python handle it using a for loop. Here the loop goes through each number from 1 to 10 and keeps adding it to the variable called sum. On the other hand, a while loop is used when you want to keep repeating something until a certain condition is no longer true. Let's say you want to add numbers only up to 5. You can use a while loop that starts at 1 and stops when the number becomes greater than 5. This allows you to automate repetitive tasks easily and efficiently. Now that we've covered variables, data structures, and loops, let's move on to one of the most important concepts in Python, that is functions. This is a block of code that's designed to do one specific task. Instead of writing the same code again and again, you can just write it once inside a function and then use that function whenever you need it. Let's say you often need to add two numbers together. You could write the addition logic each time, or you could create a function that does it for you. In this example, we've defined a function called add numbers that takes two inputs, A and B, and return their sum. Once this function is created, you can use it anytime just by calling it. And with that, you now have a solid foundation in the basics of Python. These concepts will keep showing up as we move forward to data analytics. So feel free to pause here and try a few of these examples on your own.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with iHub IIT Roorkee. Through this course, you'll get to learn data analytics from industry experts and IIT faculty in depth. You'll learn tools like Excel, SQL, Power BI, Python, and K9. This data analytics course is praised by our learners, and their user testimonials are available on our Intellipaat Achievers channel. You can check them out. The link is available in the description below. So if you are really interested in learning data analytics, this is your opportunity. Click on that apply now button right away and get started in your data analytics career journey.
Moving on to NumPy. Basically, NumPy lets you work with arrays which are kind of like Python lists. Now you guys must be wondering, if Python already has lists, why do we even need something like NumPy? I mean, lists let us store numbers, loop through them, do calculations and get things done. But while lists are great, NumPy overtake lists in terms of performance, memory and overall convenience. Let us quickly see how. So before we proceed with looking at how NumPy arrays perform better than Python lists, let me tell you that I have written some codes that include the NumPy syntax as well. But you guys need not worry about it right now because I'll be covering each and everything in detail step by step. So starting with the very first difference is speed. Okay. So consider a scenario where we have a list, and what I'm going to do is I'm going to multiply this with a really large number. So what this basically means is 1, 2, 3, 4 is repeated these many times in this particular list. Alright. So now what I want to do is I want to multiply each and every element of my list with the number 2. Alright. So basically after the multiplication, what my list is going to look like is 2, 4, 6, 8, and then again 2, 4, 6, 8, basically 10,000 times. Alright. So this is what I want my final list to look like. Now in order to implement this particular logic, what I will have to do is I will have to loop through my entire list and manually multiply each and every element with 2. Alright. Since I want to multiply it with the number 2. Now this process is going to take some amount of time, right? And in order to calculate that time, I have written down some code for you guys. So over here, as you can see, I have imported the libraries NumPy and time. Now if you guys try to import the NumPy library directly, there is a high chance that you guys will get an error. So do not worry about it right now because I will be telling you how to install it in your systems as well. So here you can see I have created my list and I have written my start time over here, and I have created a for loop where I am multiplying each and every element of my list with the number 2, and then finally I'm printing the amount of time that was required to perform this particular operation. Alright, so you can see over here it's around 1.13. Now if I do the same operation on a NumPy array, over here you can see I have created np.array. Do not worry, we'll be discussing it later. So you can see the time taken for a NumPy array is just 0.03. Alright, so this is a huge difference. Now if you guys are wondering why there is such a huge difference between the speed of NumPy arrays and the Python list, let me tell you, NumPy is built on C. Now C is a low level language. Okay, so whatever operations the C language performs are much faster compared to Python. Alright, so coming on to our next point, which is memory. Now NumPy is considered more memory efficient. Okay, now why is that? Let's quickly look at an example and understand it. So now in order to check the memory usage of Python lists and NumPy arrays, I have imported sys library, and this is my Python list and here is my NumPy array. Alright, so over here I'm going to get the size of my list, and over here I'm going to get the size of my array. Now if I run this, as you can see over here, my list size is 104 for these 5 elements and my array size is 40. again for these 5 elements. So this is why NumPy arrays are considered more memory efficient as compared to Python lists. Okay, so far we have discussed speed and memory. Now another point is direct operation in NumPy arrays. Alright, so when we were discussing the code for speed difference between Python lists and NumPy arrays, you guys must have noticed that to perform the same operation on Python list, we had to write a for loop. Whereas in a NumPy array, all we had to do was write a one-line code, right? So this is another property of NumPy array, which is called direct operation, which is also known as vectorization. All right. So let me just write it down over here. Okay. Okay. So as you can see over here, I have list down some basic differences between Python lists and NumPy arrays. The first one is speed, which we have already discussed. So Python lists are slower compared to NumPy arrays, which is mainly because NumPy arrays are based on language C or built on language C. Alright. Then we have data types. So Python list basically allows mixed data types. Alright. So you can create an array which has a number and say a letter, and then you can also have a string. And apart from that, you can also have a float. Alright, and your list is going to work absolutely fine. But in case of a NumPy array, what's going to happen is all the elements are going to be converted to a string format. So let's quickly go ahead and check it out on our notebook. Alright, so let me create a list having different data types. So, alright. So now if I were to print the type of my list A, over here you can see it's a class list and there's no particular element listed over here, right? Now if I were to create an array and store it in a variable called ARR, now if I were to say NumPy array A, then you can see over here all my elements are converted into a list type, alright? So you can see all the data types over here, being an integer, being a float, are converted into a string type, right? Because NumPy allows only same data type to be stored in a particular array. So the next one is memory efficient. So Python lists are comparatively less memory efficient as compared to NumPy array. We have already seen this. Then comes mathematical operations. So if you want to perform any sort of mathematical operations on our Python list, we will have to manually loop through them and then implement the operation on each element separately. Whereas NumPy arrays have something known as direct operations, which is also known as vectorization. Alright, so this is a very important property of NumPy arrays. Moving on to built-in functions. So Python lists have very limited built-in functions, whereas NumPy arrays have a lot of powerful tools, which we'll be looking into shortly. Alright. So let's get started with NumPy. So the very first thing you need to do is open any command prompt. It could be your terminal, it could be your normal command prompt. And all you have to do is run the command pip install NumPy. Okay. And when you run it, your NumPy library is going to get installed if it is not installed already. And once that is done, all you have to do is go on your notebook. Let me just open a fresh one. So the very first thing I need to do is, while starting with NumPy, is I need to import NumPy, and I can use an alias called NP. So you can directly import NumPy, and then whenever you want to use the NumPy library, all you have to do is use the term NumPy itself. But instead of that, I'm going to use NP. So instead of writing NumPy all over again, I just have to write NP wherever I'm calling the NumPy library. Alright, so this is known as an alias. Let me just write it down over here. So your NP is basically an alias for NumPy. Alright, so once I run it, so once you have run the pip command to install NumPy on your systems, you can go to any notebook. I'm using Google Colab. You can use VS Code or Anaconda, Jupyter Notebook, any platform. And the first step that you need to perform is import the library that you have installed, saying import NumPy. Now you can leave it at that, import NumPy, but there's a common practice of using as NP, where as NP is nothing but your alias. So generally we import NumPy as NP, and then whenever we have to use the library, we just say NP dot. Okay, we just use NP instead of NumPy. So the very first basic step is creating a NumPy array. So first we'll be looking at the inbuilt functions, and then we'll see how we can create those arrays manually using np.array function. So we can just pass a list in that array. Okay, let me just go ahead and quickly create an array, np.array. Okay, so we'll be looking at the properties and how we can implement this in detail in the later stages. But before that, I want to make a few concepts clear for you guys, like dimensions and shape of an array. Okay, so this is somewhere most people face confusion and doubts. So let us go ahead and resolve this query first. Okay, so when we have a single number, this is basically something known as scalar, and it is going to have 0 dimensions. Okay, now if I have data that is spread across one direction, that is, if say I have 1, 2 and 3, now this is going to have a one dimension. Okay, but if I have data that is spread across rows and columns, that is in somewhat this way, maybe 1, 2, 3 and 4, 5, 6, this is known as two dimensional. Okay, so let us go ahead and check this. So if I were to check the dimension of my array that I just created, I will have to store it in a variable. Okay, and so now let me go ahead and, okay, so you can see the dimension of my array is 1 over here. But if my array looks something like, so you can see my dimension for this particular scalar element, scalar value is 0. Okay, now brackets in NumPy play a very important and major role. So whenever we're defining dimensions, we'll be creating arrays in the later stages. So I'm just going to give you a theoretical overview. So is basically, if we have a single bracket and elements inside it, it is going to be a one dimension. Okay, if we have two brackets, so this is going to be two dimensional. Okay, as the number of brackets increase, so do our dimensions. Okay, let us quickly go and check it. Okay, so let me just create empty arrays. Let me just initialize the arrays using brackets. Okay, so that you guys get a more clear idea. And I'm going to pass a single bracket. And then I'm going to check the dimension of my array. So it is the dimension is checked using this function ndim. Okay, so this is an inbuilt function. You just have to remember the syntax, that is ndim. Okay, okay, so there are no brackets over here. It's just ndim. Okay, so you can see there's one bracket and there's one dimension. If I increase the number of brackets here, okay, now let's run it. So my dimension is 2 now. Now if I further increase my brackets, the dimension is 3. I can add the brackets anywhere. Okay, it does not matter. Now my dimension is 4. Okay, so now it's up to you how you are defining the array, how you are what's the shape of your array. Now if I go ahead and check the shape of my array, shape is nothing but that tells us the number of rows, the number of columns. Now over here our dimension is 4, so we are going to have data spread across 4 particular rows, right? So it's basically going to be a 4-dimensional space. So a 3D object looks like this, right? We had created this. So this is a 3-dimensional space. A 4-dimensional space would look something a little more different, a little more complex to draw right now. So basically this is how it's implemented. Now we'll move on to creating arrays using the inbuilt functions. Like the first one is going to be range. So basically, whenever we have a list, okay, say I want to create a list containing elements 0 to 10. How would I do that? I can either manually write all the numbers like 0, 1, 2 and so on, right, till 10. Or I can go ahead and create a for loop. So I will say for I in range 10, and then I will just l.append, okay, and I will insert my array. Okay, so this is what I would do for a list. But in order to avoid all these complex operations, I can directly go ahead and say np.arrange, pass the range, that is 0 to 10, and by default my step value is going to be 1, so I will not write anything and I just have to store it. Okay, so let's go ahead and see the practical demonstration or the hands-on demonstration of all these functions in our Google Colab notebook. All right. So once your NumPy library is installed using the pip command, all you have to do is go ahead and import it. All right. Now we can import NumPy using just import NumPy, but there's a common practice of writing as NP, which is nothing but an alias. Alright. So basically, whenever we use or call the NumPy library, we can use the term NP instead of writing NumPy. Alright. So this is just an alias for NumPy. You can go ahead and just directly import NumPy, but this is a common practice. Alright. So the very first thing we're going to do is try to create a range of numbers like a Python range. So let's say I want to create a range of numbers between 1 to 10. Alright. And let's store it in a variable called range. So as you can see over here, I have a NumPy array with the elements 1 to 9. Alright. So the last element, which is our stop element, is not included. And just like Python, we can also provide a step value. So say if I want to skip one value, so this is what my NumPy array is going to look like. Alright, so this is basically the start. Let me just write it down here. Start, stop, and the step value. Alright, so the start value is included, the stop value is never included, and the step value is basically telling us how many numbers to jump. Okay, by default it is 1. Alright. So moving on to the next property of NumPy, it's called linspace. Alright, so this helps us create evenly spaced numbers. Alright, so say if I want to create an array with a specific number of values which are evenly spaced between two numbers. So say I want to create, so let's create an array np.linspace, and I want to create numbers or values between 0 and 1, and I want 5 values between them. Alright, so let me print it as well. So see, I have values between 0 and 1 and they are evenly spaced, right? So 0, 0 0.25, 0 0.5, 0 0.75 and then 1. Alright, so if I were to say I want 10 values, this is what my array would look like. Clear? So basically over here, we are giving the parameters of start, stop and number of values between them. Alright. So this was all about linspace. Moving on to the next property of NumPy array. So these are basically the inbuilt functions, alright? We can create different types of arrays using a range, linspace, and the next one that we have is log space. So the name itself suggests that this is something related to the log, right? So this is nothing but a logarithmic scale array, alright? So let me again store it in ARR itself. Okay, and I want my array to start from 10 to the power 1 and end at 10 to the power 3. And I want 3 points only. Alright. So basically what I'm telling here is 10 to the power 1 to 10 to the power 3. And how many values I want between these? Basically I want 3 points. Sorry. Not the number of values, the number of points. Okay. So let me just print. Yeah. So 10 to the power 1, 10 to the power 2 and 10 to the power 3. Alright, I'm getting 3 points. Now if I were to say I want 2 points over here, let me see how it would look like. So I would get only 2 values. Alright. So np.log space, let me just make it more clear for you guys. It's basically taking the starting, or you can say the starting power value, okay, the ending power value. Over here the start end are the powers, alright, these are the powers, and then our last parameter is going to be how evenly spaced you want the scale to be. So if I want 3 points on the scale, I'm going to get 3 values. If I want 2 points on my scale, I'm going to get 2 values. Alright, so this is basically going to tell us the number of values again. Alright, so I hope this was clear. So moving on to the next property, which is np.zeros. Now what this is going to do is it is going to create an array full of zeros. Alright, so let's see how this is implemented. Okay. So let's say I want an array called ARR, which is full of zeros. So I can directly go ahead and create mp.zeros 5. Now what this 5 here is, it is going to tell me how many number of zeros I want in my array. So basically the size of my array is going to be 5. Alright, so let's print it here. Now this is basically just one line of elements, right? Okay, so another great use of NumPy arrays is that they are used for creating a matrix, which is nothing but rows and columns. Alright. So if I want to create an array which is full of zeros, but I want 2 rows and 3 columns of these zeros. So this is what I'm going to do. Alright. So basically over here I have 2 rows and 3 columns. Okay. So as you can see over here, these are my 2 rows. This is my row 1. This is my row 2. This is my column 1. This is my column 2. And this is my column 3. Alright. So when I defined in the np.zeros parameter 2 comma 3, what I meant was 2 rows and 3 columns. Alright. So you can create 2D, 3D, 4D, any number of dimensional arrays using NumPy. Alright. Say if I were to say 5, comma, I'm giving random dimensions over here. So here, this is how my array would look like. Alright. So NumPy is never going to raise an error. How many dimensions you want, you can give the parameter over here. For now, we'll just keep it limited to 2 comma 3, which is practical enough, right? So similar to np.zeros, we have another NumPy property, which is np.ones. So you guys must have gotten a basic idea. Similar to np.zeros, we have np.ones, which is basically nothing but instead of zeros, we're going to have ones in our array. Alright. So whenever we want to create an array where all the values are 1, we can use this particular function. So I'm going to create an array having the dimension of 4 comma 2. Alright. And I can also decide a data type. Alright. So if I want to give a data type over here, okay, and I want my data type to be an integer. So here you can see. But if I do not write this particular argument or parameter, by default my array is going to be a float, as you could see over here as well. Alright. So we can write, let me just comment. Similarly, this is something array full of. Alright. So previously we saw how we could create an array which was full of zeros or ones. But now we can create an array having a value of our choice. Okay. So now over here, similarly, what we were doing earlier, maybe I want to create an array having 10 elements and my default value is going to be 2. Alright. So instead of np, I wrote arr by mistake. So that's why I was getting the error. So let's print it here. So I have 10 values of 2. Alright. Now if I want to create a 2D array, I would simply say np.full and I would pass the dimensions say 2 comma 4, and I would have to pass this in a square bracket because I also want to pass a default value which is going to be 7 in this case. So my code looks neat and it's easy to understand also right now. Alright. So if I print it here, I have 2 comma 4, so 2 rows and 4 columns of the default value 7. I can pass another value here, maybe 7.1. Yeah, so 7.1, no error, smooth and easy. Alright. So let me just write it down to you guys. So it takes the parameters of row, column and a default value. Alright. So moving on to the next function is np.empty. So this is basically an uninitialized array. Okay. So whenever you want to create an array without setting any sort of values, so you can simply use np.empty. Alright. So let me store it in a variable called arr again. You guys can go ahead and create different variables, but I'm too lazy to do that, so I'm just going to use arr over and over. So over here in my empty brackets, I'm simply going to pass the dimensions, which is 2 comma 3. Alright. So let me just print it. So basically it's an uninitialized array. This is not np.zeros. This is an uninitialized array. Okay. Basically there are no elements over here. So this method is basically faster, but it's not safe unless you're going to override these particular values. Alright. So whenever you want to override these values later on in the later stages, this method is pretty good to go because it's really fast. Alright. So moving on to the next function, which is mp.random.rand. Now this function is going to generate random floats. Now floats are basically going to range from 0 to 1. Alright. So, and these are going to be uniformly distributed. Alright. So I just have to pass my dimensions. Say I want to generate 10 random floats between 0 to 1. Let me print it as well here. So I have 10 random floats between 0 and 1. Okay, and they're going to be uniformly distributed. Let me try another one using np.random.rand, and my dimensions are going to be 2 comma 3. Okay, so this square brackets is not required over here because instead of dimensions, the np.random.rand function is considering it as a list. So make sure you pass these dimensions without any square brackets, okay? Since it's not taking any default value or no third parameter, we are not going to use square brackets for these particular dimensions here. Alright, so here I have 2 rows and 3 columns, as you can see. 3 columns and 2 rows. Alright, so this was np.random.rand. Moving on to our next function, which is np.random.randn. Okay, now randn basically stands for random numbers having a normal distribution. Yeah, so Google Colabs has generated the definition for us. So basically these are the random floats from standard normal distribution. Okay, what this means is that this particular function is going to generate values from a standard normal distribution, meaning the mean is always going to be 0, mean is nothing but the average, and the standard deviation is always going to be 1. I'm sure you guys are familiar with a graph like this. Okay, so the mean is somewhere over here, which is basically 0, and our standard deviation, which is basically telling us how spread our data, is always going to be 1. Alright, this is also known as the graph for normal distribution. Okay, so in order to generate random numbers having a normal distribution, all you have to do is pass the dimension again. So I'm just going to go for 2 comma 3, and then I'm going to, okay, I haven't stored it in a variable. Let me just store it, and then I'm going to print add. So here my values are also going to be negative because again they're normally distributed, and the center is going to be 0. Alright, then the next one that we have is np.random. Random basically stands for random numbers. I hope you guys got an idea about that. Okay, dot randit. Now this is the most simple one so far. This is basically just random integers. Okay, so here we are going to generate random integers within a particular range. So over here what we are going to pass is the starting value, the stop value, and the size. So I want it in a size, and if I don't mention the size, I'm by default going to get 1 row. Okay, so let me just run this. I haven't printed ARR. Okay, so I got one random integer called 99. Okay, so I did not specify how many integers I want. I just gave a range that I want my random integer to be between 10 and 100. Okay, so it is going to be start, stop, dimension, or the number of values. Okay, so if I were to run this again having a different kind of parameter, okay, let me just do it. So now I'm going to give a dimension of say or size 2 comma 3. So here I have 2 rows and 3 columns. So basically 2 comma 3 means I'm going to have 6 random integers in my NumPy array. All right, you guys have to keep this calculation in mind. All right, so whenever we have 2 rows and 3 columns, basically we are multiplying 2 into 3. We are going to have 6 elements. All right, we'll be performing some advanced operations in the later stages. So you guys need to have this particular calculation on the tip so that you guys do not get a lot of errors later on, right? Let's do another one. Say I have 4 rows and 4 columns. How many elements am I going to have? 16, right? 4 into 4. Let's do a last one. Say I have 10 rows and 5 columns. What's the total number of elements I'm going to have? Quickly comment in the chat box. Okay, it's going to be 50, right? So this is how you can generate random integers using this particular function. Alright, so moving on to our next topic, which is NumPy data types and typecasting. Alright, so NumPy data type is basically a function that tells us what kind of data types are stored inside the NumPy array. They could be integers, floats, strings, or complex numbers. Alright, so till now we saw how we can create NumPy arrays using inbuilt functions. Right, the first one was arrange, where we basically, if we were to implement that in Python list, we would use a for loop, right? We would give the start value, the stop value, and the step value, and then according to that, we would create a list. Similarly, in NumPy array, we can just do that using the arrange function. All right. Then we saw log space, we saw linspace, we saw some random functions like rand n and just rand, right? We saw how they're implemented and their functions. All right. Now, another way to create NumPy arrays is manually. You can manually pass the integers or the elements that you want to be stored inside your NumPy array. So, for example, I want to create a NumPy array called ARR, and I will say NumPy array, and I will pass a list of all the elements that I want to be stored inside this array. Okay, so this is my array 1, 2, 3, 4, 5. All right. So if I change the data type of even a single element over here, so I basically converted 3 to 3.1, which is a float value. And now you can see all the elements in my array have been converted to a float. Alright. So as you already discussed, NumPy arrays do not allow multiple data types to be stored. So we're going to go ahead and check the type of our array. So as you can see over here, it's a NumPy array, right? Now another way we can create arrays is, say if I have a list called lst and I have a few elements in my list, say this is a string, then I have a few integers, and then I have some float values. Okay. Now if I want this particular list to be converted into my NumPy array, all I have to do is say ARR equal to np.array and pass my list in it. Sorry. Okay, so as you can see over here, all my elements inside the array are converted into a string format. Alright, so before we go ahead and check the data types of our NumPy arrays, here are a few common data types that exist. So the first one is int32. So these are 32-bit integers. So for example, the single digit numbers. Alright, then we have int64. So by default, whenever we store an integer, they are stored in the 64-bit format. It also depends on your machine specifications. So 64-bit integers are basically the larger digits. Then we have float 32. So again, they're the 32-bit floats. So basically 1.0, 3.14. But if we have a really large float value, it would be stored as float 64. And this is also the default data type of any float integer. Alright. So basically we have a lot of decimals over here. So it's going to be float 64. Then we have bool, which is basically boolean true or false. Then we have complex numbers like 1 plus 2j, 3 minus 4j. Then we have string, which is a Unicode string like hello 1, 2, 3, basically anything in double quotes. Alright, so that comes under strings. So these are the common data types that exist. So let's create an array containing only integers. So I have created an array using np.array, which consists only of integers. Alright, let's go ahead and print it. And now what I'm going to do is I'm going to check the data type. So over here it's int64. Alright, and now if I were to make even a single element over here a float value, my data type changes to float64. Alright, now if I were to make it a string, Let's see how it would get affected. So it's U32, basically specifying that it's a string data type. Alright. Now another way that we can create NumPy arrays is while we are passing our list of elements, say I have 1, 2, 3, 4. Okay. Now I want these elements to be float data type. Alright. But if I were to print the data type right now, they're in 64, right? They're integers. But if I want to convert them into float, what I can do is I can simply write d type, which stands for data type, equal to np dot float. I can leave it at float, or I can also specify 32 or 64 according to, okay, there's a typo. So here my data type is float 32. I can also convert it to float 64 instead of float 32. Here, it's float 64. So I hope you guys are getting a basic idea. But if we were to do the reverse, say I have my float values over here and I want to convert them into integer 64, what do you think would be the result? Would I get an error, or would my elements get converted to N64? So let's check it out. So there's no error. Rather, my array has been converted to integer data types. So as you can see over here, the decimals are simply lost, right? So we basically round them up, and so if there was 2.6 over here, let's see what my array would look like finally. Yeah, so we basically just remove the decimals and pass the integers whenever we're converting float to integer. And we also saw that whenever we do not assign the data types, NumPy will do that for us automatically, right? Over here, you can see we did not happen to specify any sort of data type like float or integer. But if we go ahead and check the data type over here, it's going to be float 64. Alright, because by default our elements over here are float data types. So when we go ahead and check the data type of this array, it's going to be float. So NumPy will do that for us automatically. So we're done with data types. Now let's move on to typecasting. Alright, so typecasting is basically done using the function as type. Okay, so whenever you want to convert one data type to another, we use typecasting. So this is going to create a new array with the values converted to the other data type. It is not going to change the original array. Okay. So say for example, I have my array np.array and I have my elements 1, 2, 3. So quickly comment your answers. By default, what is the data type for this particular array going to be? Okay. So if you guys have commented in 64, you guys are absolutely right, because if I go ahead and check the data type for this particular array, it's in 64, right? As we discussed, the default data type is always going to be in 64 or float 64, depending on integer and float values. Okay. So now I want to convert this particular array into float 64 instead of in 64. So what I'm going to do is I'm going to create a new array and say ARR, which is my previous array over here, dot as type, and I'm going to say np dot float 64. Okay, now I'm going to print it. So you can see my integers have been converted to float values. Alright, I can also go ahead and print the data type. So you can see the data type is float 64. Alright, similarly we can convert float to integer. So let's convert this new array to integer 64. Alright, so here, so again my new array 2 is again an integer. So I have successfully converted my float to integer over here. Now next we are going to look into something known as typecasting errors. So whenever we try to convert from one data type to another where typecasting is not possible, we get something known as typecasting error. So say for example, I have an array where my elements are 1, 2 and hello. Okay, so say all of these are strings. So even my integers over here are stored as strings. Sorry, this is going to be np dot array. Now I want to convert this particular array into an integer data type. So what do you guys think? Is it going to run successfully or is it going to give me an error? So let's go ahead and run it here. So invalid literal for int with base 10 np.string hello. So over here we have hello, which consists of multiple characters and it cannot be converted into an integer or float format. Alright, so this is what is known as typecasting errors. So we cannot convert a string into integer or float. Is that clear? So now we saw how to create an array manually, how to check the data type and how to typecast those arrays, right? Now the next thing that we're going to look at is how to create a multi-dimensional array manually. Okay, when we were using the inbuilt functions, all we had to do was pass the number of rows and the number of columns that we needed in the array, right? But if we are creating an array manually, say np.array, now what we have to do is we have to manually pass the elements in each row and each column that we want in our array, right? So this is going to be my row 1 and then I have my row 2, 5, 6. Okay. So as you can see over here, this is my first row and this is my second row. Alright. So I have 2 rows and 3 columns. 1, 2 and 3. I can also write it like this. So I hope this is more clear. So basically this is our column 1, 1 and 4. 2 and 5 is our column 2. 3 and 6 is our column 3. Alright, and these are our 2 rows. So if we go ahead and run it, right. So now why am I getting an error over here? Because these are 2 lists. Okay, so these are considered as 2 lists. I am allowed to pass only one list in my np.array function. So what I have to do is I have to place another square bracket so that this is considered as one list. Alright, now if I run it, here, if I print my array, this is what my array is going to look like. Now I can go ahead and check the dimension of my array. So as you can see, this is a 2D array because it consists of rows and columns, right? You can check the dimension using ndim function. Alright, so there's another method where we can check the shape of our array using arr.shape. And you can see over here we have 2 rows and 3 columns. So the number of rows is always going to be the first argument or the first parameter in a tuple, and the number of columns is going to be the second one. Okay. The next thing that we can do with our array is we can check the size of our array. So the size of my array is 6. Now what this means is that I have 6 elements in my array. Now we already discussed it. We can calculate the number of elements by knowing the dimension. Now we already discussed this. We can calculate the number of elements of our array by knowing the shape of our array. So if we have 2 rows and 3 columns, it is just going to be 2 into 3, which is 6. Alright. Now the next one is checking the item size. That is the size of one element in bytes, right? So we can do arr.item size. So basically each element in our array is taking up 8 bytes of memory. Alright, so this is how you check the item size. So these are some important properties of NumPy arrays. Alright, so moving on to the next topic, array reshaping, where we'll be learning about functions like reshape, ravel and flatten. Now what's the purpose of array reshaping? So say sometimes we want to change the shape of our array without changing the data. Alright, so say instead of 2 rows and 3 columns, I might want to have 3 rows and 2 columns. Right, so such array reshaping is done by the help of these functions, as you can see over here. So first let's look at reshape. Okay, so say I have an array and I have elements 1, 2, 3, 5, 6. Alright, so I have 6 elements in my array. So my reshaped array would use the function arr.reshape, where my elements would be distributed in 2 rows and 3 columns. Alright, so I can just say 2, 3. So initially my array looked like this, and then after reshaping, this is what it looked like. Alright, 2 rows and 3 columns. Now I can again reshape my reshaped array, where reshaped is my this particular array, right? 2, 3 columns. Now I want to reshape these 2 rows and 3 columns into 3 rows and 2 columns. So it's run successfully. If I print it, as you can see, I have 3 rows and 2 columns. Alright, so I hope reshape function is clear. Now moving on to the next one, which is ravel. Okay, so ravel is basically used to convert a particular array to 1D array. Okay, so whatever maybe the dimension previously, so we can just convert our reshape 2 array. Reshape 2 array is basically having 3 rows and 2 columns. So we are going to convert it into a 1D array. So as you can see over here, our array is converted to 1D again. The next one that we have is flatten. This is also going to convert your array to 1D array. Now what's the difference between ravel and flatten? So basically ravel is going to return a view, which basically means that any changes that you apply over here in this particular array are going to be reflected in your reshape 2 array. Okay, so basically this is going to return a view, whereas flatten, it returns a copy. So whatever changes you apply to the new array, that is the flattened array, are not going to be reflected in your original array. Okay, so let us just try changing something in the ravel array. So say I want my first element, that is my element at 0th index, to be 100 instead of 1. Okay, so if I make this change, I'm going to print my ravel array, and then after that I'm also going to print my reshape 2 array, which is basically the array that we converted to 1D. Alright, so let's see if both the arrays are changed or not. Yes, so as you can see, the first element of both the arrays have become 100. Okay, now if I try to use the flatten method, so I'm going to say flat equal to reshape 2 dot flatten, and I'm going to print it. So here, okay, now if I want the first element of my flat array to be 1 again, okay, now if I print reshape dot 2, reshape 2 array, so it's still 100. Alright, so any changes in my flat array are not being reflected in my reshape 2 array. Okay, so this basically means that we are creating an independent array over here, right? So I hope the difference between ravel and flatten are clear, although their functions are the same. That is, both the functions convert any sort of array to 1D array, but whenever we use the ravel method, we are basically returning a view of the original array, right? So let me just explain it over here in case you guys did not understand. So say I have my original array over here where, okay, 1, 2, 3, 4, 5 and 6. So basically I have 2 rows and 3 columns. Okay, so when I use the ravel method, my array is going to look something like this. But this variable is still referring to this particular array. Okay, but it is only returning a view that looks like this particular array, right? It's basically returning a view that looks like one dimensional, but it is still referring to the original array. Alright, so whenever we make any changes, they are directly reflected in the original array. Make sense? But when we use the flatten method, we create an independent array where we convert the original array to a one-dimensional array. Alright, so whenever we make any changes, they have zero connection with the original array. So it is completely independent. I hope the difference was clear. So moving on to the next topic on our list, that is arithmetic operations on arrays. Alright, so this is where we are going to perform the arithmetic operations. Again, NumPy lets you perform all the mathematical operations on entire arrays, element by element, without having to loop through them. Alright, so let me just create 2 arrays, where my first array is going to be np.array, and I'm going to have the elements 1, 2, 3. Similarly, I'm going to create another array, np.array, and I'm going to pass the elements 4, 5, 6. Alright, so let me run it. So the first operation is going to be addition. Now if I want to add these 2 arrays, all I have to do is print a plus b. And there, 1 plus 4, 2 plus 5, 7, 3 plus 6, 9. Alright, so I have my element wise operation, and the result, the output is clear as well. Okay, so the next operation that I have is subtraction. So all I have to do is print a minus b, and voila. So 1 minus 4 is minus 3. 2 minus 5 is again minus 3. 3 minus 6 is again minus 3. If I were to perform B minus A, we would get positive 3s here. Okay. Moving on, we have division. So all I have to do is print A slash B and there. Okay. So it's basically 1 divided by 4, which is 0.25, 2 divided by 5, which is 0.4, and 3 divided by 6, which is half 0.5. Okay. So next one that we have is multiplication. So print A star B there. So 1 into 4 is 4, 2 into 5 is 10, and 3 into 6 is 18. Alright, easy enough. Now over here we perform normal division, right? And our answer was in float. But if we want to perform integer division, all we have to do is print A double dash B. So this is going to give us integer values, right? Okay, wait. It's supposed to be B slash slash S. Okay. So when 4 is divided by 1, it is going to be 4. When 5 is divided by 2, it is going to be 2. The roundup of 2 point, it's going to be 2.5, I guess. I'm not sure. I've not really done the multiplication. So next one is 6 divided by 3, which is again 2. Alright. So you can use double slash for integer division, whereas single slash for normal division. Then next you have modulus, which basically gives you the remainder. Okay, so all you have to do is print A mod B and you get the remainder. So when you divide 1 by 4, so let us get the remainder. Well, B is divided by A. So when you divide 4 by 1, your remainder is going to be 0. When you divide 5 by 2, your remainder is going to be 1 because 2 2s are 4 and 1 is going to be the remainder. And since 6 is completely divisible by 3, our remainder is going to be 0 again. Alright. And then our last mathematical operation that we have is exponents. So this is basically the power. Okay. So all I have to do is print A double star B. Or I can just do every element raised to the power 2. Okay. So basically I'm squaring the array A. Alright. So it is going to be 1, 2 2s are 4. And 3 to the power 2 is 9. Okay, so as you can see, this is our output. So these were the element-wise operations. Alright, so that was all about the mathematical functions. Now let's move on to our next topic, which is universal functions, or also known as U-funcs. So NumPy basically comes with many built-in math functions that work element by element, and these are called U-funcs that we just discussed. So for this particular section, I'm going to create another array using np.array and pass my list as 1, 4, 9 and 16. Alright, let's run it. So my first universal function is square root, which is written as np.sqrt. Alright, so let's go ahead and implement it. So all I have to do is print np.sqrt square root and pass my array as a parameter. Alright, so I want you guys to comment quickly what's the square root going to be for this particular array over here. 1, 4, 9, 6. 1 is going to be 1, 4 is going to be 2, 9 is going to be 3 and 16 is going to be 4. Let's see if that's the answer. Right. So you can see this is the answer, but it's returned in float data type. Alright. So moving on, the next function that we have is exponential, which is nothing but np.e to the power exp. Sorry, np.exp, which is also written as e to the power x, where x is any integer. Alright. So let's go ahead and implement it. So I want to print np.exp and say I want to print the exponential of only 1 and 2. Okay, so I'm going to pass it as a list, these two particular elements, and that. So e to the power 1 is 2.7 and the remaining decimals, whereas e to the power 2 is 7.389 something. I hope that's clear. So these are somewhat very basic mathematical functions that we will be using most of the time. So it's very important that you guys know the syntax and how to implement these functions, right? You can always go ahead and look them up online, but again, that's very time consuming. So it's particularly important that you guys remember the syntax somewhat, right? So the next one is sine function, which is nothing but np dot sine. Okay. So say I have a few angles where np dot array is equal to 0, np dot pi. Np dot pi is nothing but the pi, right? So it's written as np dot pi. And then np dot pi by 2. And then what we're going to do is we're going to print np dot sine and pass angles as a parameter. Alright. So the sine of 0 is 0, sine of pi is 1. So you can see the sine of 0, pi by 2 and pi. Alright. So this is your resulting array. So this was all about the inbuilt mathematical functions. Now we'll move on to a very important topic, which is known as indexing and slicing. Alright. Now for all those who are not familiar with the concept of indexing and slicing, let me quickly tell you guys using a list. So say I have a few elements in my list. Now if I want to access the first element of my list, which is this, all I have to do is note down the indexes of these elements. Now indexes are something that represent the value at which these elements are stored, right? So this is what my indexes are going to look like: 0, 1, 2, 3, 4. Note that the indexes always start from 0. Alright. So if I want to access this particular element, all I have to do is look up the index of this particular element. Now I know that my element is stored at index 0. So all I have to do is access my index 0, and this would give me the result 1. Alright. Now this is normal indexing. There's something known as negative indexing as well. Alright. Now negative indexing basically starts from the last element. So this is going to be -1. Note negative indexing starts with -1 and not 0. Alright. So this is going to be, our last element is always going to be -1. And then we are going to count backwards: -2, -3, -4 and -5. Alright. Now if I want to access the last element, I can either say element at index 4, or I can say element at index -1. Now both of these are going to give me the value 5. Alright. So this is something known as indexing, where you refer to the indexes and access one particular element according to the index. The next thing that we have is slicing. Slicing is where you try to access a piece or a slice of your list or array, right? Now say if I want to access the first 3 elements of my list, all I have to do is access 0, 2, 4. Now why have I used 4 over here? Because I want the first, sorry, I'll be using 3 over here. My bad. I'm really sorry about this. Yeah. This is my starting index. This is my ending index. Okay. And the ending index is never included. So this particular array is going to give me the output 1, 2 and 3. The first 3 elements of my list. Okay. 0, 1 and 2. 3 is not going to be included in my output. Alright. Now if I want to access the last 3 elements of my list, all I have to do is -1 to -4. Right? Because I want the last 3 elements of my list. So I'm going to do -1 to -4. Now another thing that I have to do here is I have to give a step value that is -1. That is, I have to tell the computer that I want to subtract 1 from the starting point to reach -3. Alright, because by default over here, as you guys must have noticed, the step value is going to be 1. That is, 1 is going to be added to the starting value until it reaches the end value. Alright, so basically we're running a loop over here. So over here I will get the values 5, 4 and 3. Alright. If I were to not include the step value as -1 over here, my output would have been just 5. Let us quickly run it and see. Alright. So say I have my list 1, 2, 3, 4, 5. Okay. Now I want to access the last three elements, that is 3, 4 and 5. So what I'm going to do is minus 1, 2, minus 4. Okay, I am not including the step value over here. So let's see what's the output here. Oh, it's empty. So it's not including the last element as well. So as you can see, I've created my list over here. Now, if I want to access the last three elements of my list, that is 5, 4 and 3, all I'm going to do is pass minus 1 as my starting index, minus 4 is as my ending index, and right now I'm going to skip this step value to show you guys that my output is going to be 0. Like that is an empty list. Alright. So I'm not even going to access repeat. So I'm not even going to get my last element in my output. Now if I include the step value as minus 1, here you can see 5, 4 and 3 is my output. Alright. So this is basically how indexing and slicing works. I hope you guys got a basic idea. Let me show you guys a normal slicing as well. So basically I want to access all my elements, but I want to access them skipping one value from them. So basically I'm going to give my step value as 2. So I want the first element, the third element and the fifth element. So let's see how this looks. So as you can see, I've got my first, third and fifth element. Okay. Now let's apply the same thing for our NumPy arrays as well. Alright. So I'm creating an array, np.array, and I'm going to have my elements. Alright. So let us quickly see the indexes first. So this is going to be index 0, 1, 2, 3 and 4. Alright. So we have 0 to 4 indexes. Now if I want to access my indexes 0, 2 and 4, that is 0, 2 and 4, what is my syntax going to look like? So let's go ahead and slice it. So I'm going to say from starting to ending, but my step value is going to be 2. So as you can see, 10, 30 and 50. Okay. So I hope I'm making myself clear. Over here, I could have passed 0, 1, 2, 3, 4. Yeah. So I could have passed 0 and left this blank because I want this to be included as well. So, but instead of that, I'm going to leave this blank as well. So by default, this is starting index, that is 0, and this is the ending index, that is the length of the array. Alright. So this is how you can slice your NumPy arrays. Now let's look at negative indexing. So let's say I want to access my last element. All I'm going to do is, so it's giving me np.in6450 as the output. Correct. But if I say print, so 50 is my output. That is the element at index minus 1. Similarly, you can go ahead and try negative indexing with other arrays and other elements. Okay, you can go ahead and play around with it. The main, the important thing is that you understand the logic behind it, right? And I hope I've explained the logic pretty well over here for both negative indexing, slicing and negative slicing. Alright, so we have already looked at slicing over here. We've looked at negative indexing. Now let's go ahead and perform multi-dimensional slicing. Alright, so I'm going to go ahead and create a matrix. I'm going to call this 2D array a matrix, and it's going to look like this. So I'm going to have 3 columns and 3 rows, 4, 5, 6 and 7, 8, 9. Okay. Now I need to convert this entire thing into a list so that I do not get any error. So that I do not get any errors. Let me run it. Alright. So now say I want to access the first 2 rows of my matrix. How am I going to do that? So in order to do that, all I have to do is print matrix and my row 0 and 1. Alright, so I want my first row and my second row. So I'm going to say row 0. So this is my row 0, this is my row 1 and this is my row 2. I do not want the second row, so I'm going to have my stop value as my second row. Alright, again the indexing is going to start from 0. So this is our row 0. Alright, so this was about my rows and I want all my columns. So I'm simply going to pass 0 to 3. That means I want my 0th column, my first column and my second column. Alright. So instead of this, what I could have done is just passed a colon. So let me see here. 1, 2, 3 and 4, 5, 6. Let me explain it over here. So I have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This is column 0, column 1, column 2. This is row 0, row 1, row 2. Alright. So basically this is what my matrix looks like. Now I am saying that I want to access this particular section of my matrix. So over here I want my row 0 and 1 and I want my column 0, 1 and 2. Alright. So over here my starting index should be 0 and my ending index should be 2. Over here my starting index should be 0 and my ending index should be 3 because I want my second column as well. Alright. So whenever we are accessing all the elements of a particular row or column, all we are doing is using the colons. We have used this feature when we were performing slicing as well. Alright. So this is basically what we have done over here. Now we can try some other elements as well. Say I want to access these 4, that is 5, 6 and 8, 9 elements. So what I'm going to do is I'm going to print my matrix and I'm going to say that I want my row 1 and row 2. So I'm going to say row 1 and I'm not going to pass any value here because I want my last row as well. Alright. And then I'm going to say I want my row 1 and 2. So again I'm going to pass 1 colon nothing. Let's print it. So I've got 5, 6 and 8, 9 as my output, which is exactly what I wanted. Alright. So I hope you guys are getting a basic idea about indexing and slicing in 1D arrays and 2D arrays, and I am 100% sure that you guys can go ahead and perform it in 3D arrays as well. Alright. So let's move on to our next topic, which is index arrays and np.take. So index arrays are also known as advanced indexing. Okay. So let's quickly see what it is. So instead of filtering with true or false, we can directly pass positions or indexes to get specific values. Alright. Okay, so let's look at another method called np.take, which is basically a built-in function to perform indexing or slicing. So whatever indexes you want to access from your array, all you have to do is create a list of those indexes. So I'm going to use this particular array. Okay. So I want to access my indexes 0 and 2. Alright. So I have defined them in a list. So now all I have to do is print np.take, pass my array and the indexes that I want to access. Okay. So as you can see over here, at index 0 I have 10 and index 2 I have 30. Alright. So you can use np.take to perform the same operations. Moving on with our next topic, that is iterating with nd iter. Okay. So in case you want to loop through the NumPy arrays, you cannot use a for loop, but rather you can use something known as nd iter. So it's going to let you loop over each element regardless of which shape it is, right? It could be a 2D matrix, a 3D matrix. You can easily loop through it using nd iter. Okay. So I have an array np.array and it's going to be a 2D array having 2 rows and 2 columns. Okay. So let me run it. So all I have to do is for x in np.nd iter my array, and I have to print x end equal to, so that it gets printed in the blue line. Alright. So you can see these are the elements of my 2D array over here. Alright. So you can use nd iter, or another feature or method that you can use to iterate or loop over your array is nd enumerate. So over here, using this, you will get both your index value plus your value of the element value. Alright. So I'll use the same array. Okay, I'll use the same array, and I'm saying for ind, which is my index, and x is my value or the element, in np.nd enumerate my array, and I'm going to print my index and my x. Alright. So at index 0, 0, that is first row, first column, I have my value 1 and so on. Alright. So you can easily understand this. So moving on to views versus copies. Again, this is a very important topic. Okay. So we already saw that when we create a view, the original array is going to be affected, whereas whenever we create a copy, our original array is going to remain unchanged. Alright, so let's see how we can create a view. So if we have an array, let's create np.array. Okay, first I'm going to create a view. So my view is going to be array 1 to element. Let me print my view. So it's elements 2 and 3. Alright, now if I try to change my view, let's say I want my first element of view to be 200 instead of 2. Okay, let's check my view. It's array 203. Now if I try to print the original array, it has also been changed, right? As you can see over here, instead of 2, I have 200. Now let's try and create a copy. Okay, so in order to create a copy, all I have to do is say arr 1 colon 3, that is elements 2 and 3 dot copy. Okay, now over here my array is going to look the same as what it looked in a view, but over here if I say my first element needs to be 2 again, over here it's changed, but if I print the original array, the element remains unchanged. Alright, the values are same as before. So this is the difference between view and copy. We had covered it theoretically, but now we have also seen the practical implementation of the same. So moving ahead, let's look at a very important mathematical concept in matrices, or whenever we have more than one dimensions in an array, something known as transpose. So we're going to look at transpose of a matrix. So say I have a 3 by 3 matrix containing values A, B, C, D, E, F, G, H, I. Okay, so this is a 3 by 3 matrix. Now what transpose basically means, so transpose of a matrix is basically a new matrix created by interchanging its rows and columns. Alright, so if this matrix is denoted by A, my transpose matrix is going to be denoted by A dash or AT. Alright, so this is going to be the transpose of my matrix. Now what interchanging rows and columns basically means is, if I want to transpose my matrix, so this is what my transpose is going to look like. So let's see how it is done using NumPy in our notebook. Okay, so let's create another array, np.array. Okay, 1 comma 2 and 3 comma 4. So you can see 1 and 2 are spread row wise and 3 and 4 are the other rows, whereas 1 3 is first column and 2 4 is the second column. Now if I go ahead and print arr dot transpose, you can see my rows and columns have been interchanged. Alright, so now 1 3 is spread row wise instead of column wise, and 2 4 is spread column wise instead of row wise. Alright, moving on to the next topic, swap axis. What this means is we swap two specific axes in a matrix. Alright, so I'm going to consider this particular array itself. Let me just copy it. Okay, now let's quickly see the shape of my array. So arr dot shape. Okay, so it's 2 comma 2. So I need to change this into, okay, let me add another axis to it. Okay, so now it's 1 comma 2 comma 2. Alright, now if I want to swap an axis, I'm going to say np dot swap axis, and I'm going to pass my array, and I'm going to say I want to swap my 0th axis with my first axis. Okay, now I'm going to check swap dot shape. So now you can see these two axes have been swapped. It was 1 2, now it is 2 1. Alright, so basically you can choose over here which axis you want to swap. That's the only function of swap axis. Alright, now let's look at some other functions like concatenation. So concatenation is basically when you join multiple arrays. Okay, so let us quickly look at concatenation. Okay, so say you have array 1 of 1 comma 2 and you have array B 3 comma 4. Now you want to concat these two arrays, that is basically you want to join them. So you can say, so that your result basically looks like 1 2 3 and 4. Alright, so in order to achieve this result, all we have to do is, if we had the plus sign, remember our element wise operation is going to take place. That is, if we simply perform A plus B, if that is what you guys are thinking, it's completely wrong, because our result is going to look like something like 4 comma 6. Okay, if we do A plus B, we've already seen that in the addition operation. So in order to do that, what we're going to do is, Let me just create the arrays. Okay, so let me run it. Now, in order to combine these two arrays, all I'm going to do is concatenate and pass both my arrays and then print my combined array. Okay, so my combined array looks something like this. Now, there are other ways to combine these arrays. Now, what if I want to combine these arrays not like this, but rather something like 1, 2 and 3, 4, and I want my array to look like this. Okay, so in order to do that, there is something known as V stack or vertical stack. Okay, so this is where you can understand. This is how I understood. So say if I have two arrays A and B, they must be having, okay, let me call it A1, B1. So they have these particular elements, okay, C, D. Okay, and array B looks something like. Now, if I want to perform vertical stack on these two arrays, my output is going to look something like this. Okay, so my final output is going to look like A, B, C, D. I'm not going to focus on the brackets right now. I'm more focused on the output P, Q, R, S. Okay, so basically this is how my output is going to look like. Let me just go ahead and implement it. So I have my array1 nt.array and I'm going to pass A, B, C, D. Okay, I think I have to put them in quotes. So instead of that, I'm just going to replace them with numbers itself. And my array 2 is going to be, okay, so these are my two arrays. Now, if I perform vstack, which is np.vstack, and pass array 1 and array 2, you can see this is what my output is going to look like. Now, similarly, similar to vstack, there is an other operation called hstack. Okay, now vertical, remember vertical is like this, where your two arrays are going to be stacked like this, whereas horizontal stack, remember it as the horizontal line, where your arrays are going to be stacked like that. Basically, they're going to be concatenated. Alright, so in case of horizontal stack, my output is going to look like this. Okay, so it is going to be A, B, C, D, okay, P, Q, and R, S. Okay, let us quickly perform hstack. So if I were to print np.hstack and pass both my arrays, you can see this is my output, just as we discussed. Okay, so basically it's going to be concatenated or joined horizontally. Alright, so I already told you the easy way how you can remember this. Whenever we're talking about vertical stack, all you have to do is imagine a vertical line and then imagine the two arrays following that vertical line and finally combining. Whereas in the horizontal stack case, you imagine a horizontal line and imagine the two arrays following the directions and combining. Okay, so that's all about a horizontal stack and vertical stack. Now, if you don't want to particularly call hstack or vstack, what you can do is just call stack. Okay, and now this stack function is first going to take your arrays, that is A, B, and then it is going to ask for your axis. Okay, now always remember, axis 0 means row wise, whereas axis 1 is column wise. Okay, so this is something that you will have to remember. So say I print np.stack, I pass my arrays and I give my axis 0, which is basically going to be performed row wise. Alright, so axis 0 means rows. So whenever we're going to stack our rows, they're going to be stacked vertically. Whereas if my axis were 1 over here, my arrays would be joined column wise. Okay, let me just change this to 1. So our axis can only be 0 or 1. Okay, so this was all about joining or combining two arrays. Now let's look at the opposite function of that, that is splitting the arrays. Okay, so this is my array. Let me just print it. Okay, so this is what my array looks like. Okay, now if I want to split my array into two equal parts, all I'm going to do is print np.split arr1 and I'm going to say two parts. Alright, so this is my array 1 and this is my array 2. Now if I say I want to split it into three parts, I get an error because there won't be an equal division if I go for three parts. But if I go for four parts, you can see I get four different arrays. So in order to avoid error, you will have to do some prior calculations. Okay, you need to make sure that your array is eligible to split in those many parts equally. Alright. So if we perform hsplit on our array and we say we want to split it into two parts, this is what our array is going to look like. Alright. So it's basically split into two parts. We've already discussed edge split is going to be performed this way and vertical split is going to be performed this way. So similarly, you can perform B split as well. You just have to pass the array and the number of splits you want to perform. Okay, you need to make sure that that number satisfies the basic requirement, that is the array is able to divide itself into equal parts. Alright, so moving on to the next topic, that is repeating and tiling. So first we'll look into repeating. So the repeat function basically repeats each element. Alright, so say I have an array over here that contains the elements 1, 2 and 3 and I'm going to perform the repeat operation saying np.repeat and I'm saying I want to repeat my array twice. So if I print it, you can see each element is repeated twice. Okay, so if I repeat it thrice, this is what my array is going to look like. Now the other operation is tile. Okay, now this is going to repeat my whole array. Okay, so I can simply say print np.tile array twice. Okay, so 1, 2, 3 and 1, 2. Alright, so this is all about repeat and tile. Then we have some aggregate functions. Okay, so aggregate functions are basically used to summarize the entire array. So say for example, you want to find the total, the average, or the maximum element or the minimum element. Now in case of Python list, normally you would have to loop through the entire list and perform these operations. But NumPy arrays come with inbuilt functions. So say for example, this is my array. Okay, and if I want to find the sum, all I'm going to do is print np.sum and pass my array. Alright, so I have the sum of all my elements. Similarly, I can find np.mean, that is the average. So my average is going to be 2. 6 divided by 3. Alright, then I can find my median. So my median is 2 again, that is the middle value. So 1, 2 and 3. Then I can find the standard deviation, np.std. Okay, and similarly I can find the variance. This is basically the square of my standard deviation, and standard deviation is basically how spread your data is, your numbers are. Okay, then we can also find the minimum number or the minimum value in my array. So my minimum value is 1 and the maximum value is 3. Alright, now if I have a 2D matrix and I want to find the sum across any one axis, I have some axis based operations that we can apply along any row or column in a 2D array. Okay, so say I have a matrix np dot. Okay, let me just see if I have a matrix already. Okay, so I have this matrix already. So if I want to find the sum across only my columns, okay, so what I'm going to do is print np.sum and I'm going to pass my matrix and I'm going to say axis is 1 because I want it across my column. So since my axis is 1, the sum of this particular row is 6, then over here it's 15 and over here it's 24. Now similarly I can find row wise operations as well. So 1 plus 4 plus 7 is 12. Okay, so this way you can do your row wise or column wise operations as well. Then next we have cumulative operations. Okay, so these are basically for calculating a running total. Okay, let's see how. So here I have my array 1, 2, 3. Now if I want to print the running sum or the cumulative sum of my array, I will just say mp.comSum, pass my array, and you can see the sum of my first element is 1, then sum of my first element plus my second element is 3, then sum of my first element plus second element plus third element is 6. Okay, so this is how a running total or a cumulative sum is calculated. Similarly, you can also calculate a cumulative product, saying np.comProd and pass my array. So 1 multiplied by nothing is 1, 1 multiplied by 2 is 1, 1 multiplied by 2 multiplied by 3 is again 6. Alright. Now moving on to conditional based choices. Okay. So first we are going to look at where. So say I have my array over here 1, 2 and 3. Alright. So I'm going to call my result variable and I'm going to say np.where array is less than 2. I want to print low, and if my array value is greater than 2, I want to print high. Alright, so let's print my result. So here I have my result array saying low, high, high. Okay, so over here my value is less than 2, so I have printed low over here. Whereas over here these two elements are greater than 2, so over here we have high. Alright, so again, this is the string format and this is how it's represented. So the next feature is argware. So this basically gives the row column positions for 2D arrays wherever your condition is satisfied. So this is my array over here and I want to find out wherever my elements are greater than 20. Alright, so it's telling me at index 1, 2 and 3 I will find my elements greater than 20. So at index 0 I do not have my elements greater than 20. But what if I change my condition to 0 over here? So you can see I have my index 0 also in the output. Alright. So let's move on to advanced conditionals using np.logical and logical or. Alright. So this is my array and now if I want to get values between 15 and 35, all I have to do is let's create a variable mask and np.logical and arr greater than, that is my array, greater than 15 and array less than 35. Alright, so let's print mask. So over here it's false, over here it's true, that is 25, it's greater than 15 and 35 is again not less than 35 and 50 is again greater than 35. Alright, so you have false over here. Alright, so this was an example for a 1D array where we just had 3 elements. Now let's try for a more complex array, NumPy array. Let's take a 2D array. We already have a matrix over here. Alright. So now let me give a condition where I'm going to define np.arg_where and I'm going to say wherever my elements in the matrix are greater than 5, give me the index of those particular elements. Alright. So you can see over here, the first element that's greater than 5 is 6 over here, right? So the index of this element is row 1 and column 2, alright? So you can see over here, 1, 2. Then the next element that is greater than 5 is 7. So you can see over here, 2, 0. Then we have 2, 1 for element 8 and value 9, we have 2, 2, alright? So this is basically how np.argware works, alright? It's going to return the row it's going to return the row column of your value wherever the values satisfy the condition. Alright. So moving on to our next topic, that is advanced conditionals using np.logical and logical or. Alright. So basically we have and or in Python, but in NumPy we use logical and logical or. Alright. So in order to understand that, let me quickly tell you guys about this concept. So whoever is not aware about the concept of and or in Python, let me tell you. So say I have these particular values, alright? So now if I implement an and over here, that is a logical and between these two values, I'm going to get a 0. But if I implement a logical and between 0 and 1, I'm still going to get a 0. Between 1 and 0, I'm still going to get a 0. But whenever both my conditions are true, basically 0 stands for false and 1 stands for true. Okay, so basically over here what it means is if any one of my condition is false, my and result of that false and true condition is always going to be false. I am going to get a true only when both my conditions are true. But in case of or over here, we're going to get a result like this because whenever we have any one statement, any one condition true, our result is going to be true. Alright. So this is basically what logical and logical or mean. Okay. So first let's go ahead and look at logical and. So we have an array. Let me just print my array. Okay. So this is my array initially. So what I'm going to do is I'm going to get my values between 3 and 6. That is I want 4 and 5. So all I'm going to do is np.logical and I'm going to say arr greater than 3, comma, my array should be less than 6. Alright. So if I run it and if I print my mask, so over here I get my false, 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 true, true for 4 and 5. Now if I say arr here, so I get my values 4 and 5. Okay, just like we intended. So this was the implementation of logical and. Now moving on to logical or. Okay. So over here, I want all the values other than 4 and 5. Okay, I want to skip these values and I want all the other values. So what's going to be my logic over here? Let me create my mask variable again. So I'm going to say np.logical or and I'm going to say my ARR, that is my array, should be less than 4 or my array should be greater than 5. So let me run it. Okay. So you can see for 4 and 5 I'm getting a false. Now if I try to fetch these values, so wherever I'm going to have a true in my array, those values are going to be printed. Alright, so you can see 100, 2, 3 and 6. Okay, so I hope the implementation and the logic behind logical and logical OR is clear to you guys. So before we move on to our next concept, let us quickly go ahead and summarize the concepts or the important functions that we have covered so far. Alright, so the first one is Boolean mask. That is basically we want to select the values based on true false conditions. Alright, so here you can see we have created a mask variable. So once we get our array of true or false, we simply use that particular array to index the original array and get the elements that are desired. Alright, so we saw how we use the Boolean mask array to select the values based on true false conditions. Then we also saw np.take, which basically performs the operations of indexing and slicing. So it basically fetches the values at given indices. Then we have np.non-zero. Okay, so this gets the positions where the array values are non-zero. Alright, so let me create an array having, sorry, I have to say np.array 0, 1, 2, sorry, 5, 0, 5. Okay, so this is my array. Okay, now what I'm going to do is print np.non-zero and I'm going to pass my array. So you can see these are the indexes where my elements are non-zero. Alright, so at index 1, at index 2 and at index 4. Alright, so the non-zero function is clear. So it's basically going to get you the positions where the array values are non-zero. Alright, then we saw np.where. So basically the where condition is going to get us the indices where the condition is true. But we already saw that one limitation over here is we can only pass two conditions, right? So we already saw the syntax where we say np.where and we give a condition and we tell, so if the condition is true, this particular operation gets performed, otherwise the other operation is performed. Alright, so we can only have two conditions over here. Alright, so pick from A, else pick from B. Then we have np.argwhere. So this is where we get the row column positions of matched values. Okay, we already saw this. And then lastly we have logical and logical OR. Alright, okay, so basically we are done with all the inbuilt functions that exist in NumPy. So now we'll be moving on to a very important topic, that is broadcasting. Okay, so what exactly is broadcasting? So broadcasting basically means stretching the shape of smaller arrays so that they match the shape of bigger arrays. So whenever we are doing an operation like addition, multiplication, subtraction, any kind of mathematical operation between two arrays, and one of our array is smaller as compared to the other arrays, so broadcasting is basically going to automatically stretch the smaller array to match the shape of the bigger array. Alright, so basically as a result you will be able to perform these operations between those two arrays. Alright, so before we go ahead into the implementation part, here are three very important rules that you should know when you are going for broadcasting. Alright, so always remember that NumPy is going to compare the shapes of the arrays from the end, that is from right to left. Okay, so if we have two arrays, they are going to start from the end. So the first rule is if the shapes are equal, they are compatible. Alright, so if we have two arrays that have the same shape, we do not need any sort of broadcasting to be implemented. They will be compatible directly. But if one is 1, it can be stretched to match the other. Now what this means over here is, so if we have one array like this, 1, 2 and 3, and the other array is just a single number 5. Alright, so say over here I want to add these two arrays. Now over here what NumPy is going to do is, it is going to perform broadcasting and this particular array is going to look like this. Alright, so over here initially this was a scalar array, but over here you can see this has become a 1D array. So if we perform this operation, it is going to look something like this. So rule 2 and rule 3 are related. if we read it just like that, it might not be very clear. So let us go ahead and understand this with another example. So say I have an array whose shape is 3 comma 1. All right, so basically over here we have 3 rows, say 1, 2 and 3, and 1 column. All right, so this is what my array looks like. Then I have another array who has a shape 1 comma 3. All right, so this array is going to look like 1 row and 3 columns. All right. Now, if we were to perform broadcasting between these two arrays and say we perform some mathematical operation like addition, subtraction, multiplication, any sort of operation between these two arrays, our final array, our resultant array, due to broadcasting, would have a shape 3 comma 3. Alright. So basically, after broadcasting, this is also going to be 3 comma 3 and this is also going to be 3 comma 3. And that is how we get a resultant array that will have a shape 3 comma 3. Alright. So say for example, I have an array over here. Now what's the shape of this array going to be? The shape of this array is going to be 3 comma 1. Alright. So basically it's going to have 3 rows and 1 column or in each row. Alright. And then I have another array that looks like 1, 2 and 3. Now the shape of this particular array is going to be just 3, right? Because it has 3 elements, right? It's not a 2D array, it's a 1D array. So whenever we have to write the shape of a scalar dimensional array, we write it like this, 3 comma, okay? We leave it blank. But now due to broadcasting, this particular element will look something like 1 comma 3. So basically we're going to consider this as 3 particular columns and this is 1 row. Alright. Now after stretching these two arrays, our final array is going to look like 3 comma 3. Okay, it's going to have the shape of 3 comma 3. So according to rule 2, whenever any one of the array has 1 in its shape, it can be stretched to match the other array. Alright. Now let's look at another example where one array has the shape of 2 comma 3 and the other array has the shape of 3 comma 2. So why any operation is not possible between these two arrays? Because neither of these arrays have the shape of 1 in any particular row or column. Alright. So I hope the rules are clear. So if the shapes are different and not 1 or equal, then broadcasting cannot be done. So this is the only case where broadcasting cannot happen. So say if shape of B was 1 comma 2 or 1 comma 3, then broadcasting could have happened between A and B. But if the shape is 3 comma 2 where 1 is not there, then any operation is not possible and broadcasting will not take place. You will get an error. Alright. So now let's look at some real life examples where broadcasting is used. So say you have a grayscale image stored as a 2D array. Alright. Now you want to increase the brightness of the image by 50. So let me create a 2D array of the image, np.array, and so this is what my image array looks like. Alright, and I want my brightness to be image plus 50. Okay, I want to increase it by 50. Now if I print brightness, you can see it has been increased by 50. Overall my array has been changed. Alright, so over here 50 was broadcasted from a scalar digit to a array similar to this. Alright, so let's also check the shape of this 2D array. So it was 2 comma 2. So basically 50 was distributed in a 2 comma 2 matrix and then it was added in the image. Alright, so this is basically what's happening behind the scene that NumPy doesn't really want us to get bothered with. Alright. So that was all about broadcasting. I hope you guys got a basic understanding of the rules. The second and third rule are very important. If you guys did not understand it, you guys can go back and watch that particular section again. So moving on to the next topic, which is vectorization. Okay. So we already saw vectorization is basically when we replace the loops with array operations. Alright, we already saw array have numerous inbuilt operations that perform the mathematical operations directly, right? It could be sum, minimum element, maximum element. Any sort of operation that we want to perform on the list through loops can be done on arrays with a single function. That is known as vectorization. Now why this is possible? This is possible because of NumPy being run on the compiled C code in the background, right? So it's basically much faster than Python as well. So now why are we looking at vectorization again, since we have already covered it in detail in using all the functions? Another important property of vectorization is, say I want to create a new function. I want to do something different that the inbuilt functions are not able to do as yet. So what I can do is I can write a function and I can convert that particular function into a vector. Basically, I can vectorize that function. So let's see how. Okay. So we are going to use here np.vectorize. Okay. So this is going to convert a regular function to be applied on an array. Alright. So I hope this is clear. So we'll go ahead and create a simple function. I will not do anything complex. Say I just want to create a function where I want to square all my elements. Okay. So all I will do is create the function. Now what I'm going to do is I'm going to create a variable vfunc, which is basically vectorized function, and I'm going to call np.vectorize, and I'm going to pass my function. Okay, so this is my array, and now all I have to do is print vfunc and pass my array. Okay, so you can see my array has been squared. All the elements have been squared in my array. Alright. So now you saw how you can basically convert any normal function into a vectorized function, but vector functions are to be used only when you want to apply a custom function to every element, and it is good for readability as well. So these are basically the benefits that you achieve when you're using a vectorized function. But there are some disadvantages as well. Okay, so it's not faster than a loop. Okay, basically you are going to pass your array into that function and the entire process is going to be performed. So it's not comparatively faster to a loop. The only thing it does is it makes your syntax cleaner, but it is not going to improve the speed like a real vectorized NumPy function or a NumPy array function. Alright. So if your purpose is not to increase the speed, you can go ahead and create vectorized functions. But if your motive is to increase the speed of your program or your code, then you should prefer the built-in NumPy functions like np.sqrt, np.exp that we just discussed. Alright. So now we'll move on to the last part of our course, which is dealing with missing values. Okay. So basically, whenever you have a data with you, okay, it could be any particular data. You will be having, say, let's say I am creating a house price prediction model. Okay. I'm going to have features like number of bedrooms, bathrooms. I'm going to have the location of the property. Okay. I'm going to have a number of features. All right. Features are basically the columns in your data set. Okay. So whenever I have a data set, there are going to be some features where I am not aware of what data is over there. Okay, so basically that's called a null value. Okay, so whenever you're dealing with a data set, there are going to be cases where you do not have the complete data in your data set. What I mean by that is maybe you have uh, some data like this. So now wherever you see null written, that means that particular data is not available. Maybe the person forgot to update it. It could be any reason. Okay, so what do you do when you are in a situation like this, when you have some data and some data is missing? So this is where NumPy comes in the picture. NumPy is going to help you deal with all these missing values in your data set. Alright. So the very first feature that helps you deal with missing values in NumPy is np.nan. Okay. NaN basically stands for not a number. Okay. So this is used to represent the missing or undefined value. Okay. So let us see how it's implemented. So I have an array over here where my data looks something like 1, 2, np.nan 4. Okay. So you can see over here, NaN means not a number, means the value which was supposed to be here is missing. Alright. Then we have other functions like np.inf, sorry, minus np.inf. Okay, see, these basically represent the positive and negative infinite values. So they often appear where in cases like division by 0 or overflow situations. Alright, so I'm going to write positive and negative infinites. Okay. So again, instead of np.nan, you can just write np.inf. Okay. So I'm not going to go ahead and create an array separately. Rather, I'm going to jump to the next step, that is when you check for the special values. So here you can check if your array has any NaN, INF or negative INF using special functions like np dot is NaN, np dot is INF, and np dot is finite. Okay. Used to detect any sort of null value, infinite value, or finite value. Okay. So let's go ahead and see how it's implemented. So let me create an array first that has all these criteria checked. Okay. So first we're going to use is NaN. Alright. So I already have an array over there. So all I'm going to do is print np dot is NaN, and I'm going to pass my array A. So over here you can see at index 2 I'm getting a true value. That means at index 2 over here my value is NaN, that is not a number. Okay. Similarly, I'm going to create other arrays like np dot array, and I'm going to have values like np dot null, np dot inf. Let me pass this in a list. So now over here I'm going to check for np dot is inf and pass my array. So I'm getting true at position 2, that is index 2 over here np.inf. So over here I'm not going to be made aware of any null value or not a number value. Okay. So if I want to find out null value as well as infinite value, what I can do is I can use np.logical or, and I can say np.na, sorry, is NaN. So first we looked into these functions, what NaN did, what INF did, and what negative INF did, right? And then we saw how we can find these null values or infinite values in our arrays. Now once we have found these values, the next step would be to replace or remove these values. So how that can be done? That can be done using np.nan underscore to underscore now. Okay. So let me create a new array and let me pass array B. So if I print my new array, so as you can see over here, all my values have been changed. So basically the null values are going to be replaced by 0. The infinitely large values or infinite values that are positive are going to be replaced with a large number, whereas any negative infinite value is going to be replaced with a negative large number. Alright, so this is what np.nan to num does. Okay, so let me just write over here, remove not a number or infinite values. Alright, so this is what it does. In the last section, we had covered NumPy. So before we move ahead with pandas, I want you guys to understand the basic difference or the basic requirement why we need pandas. Alright, so basically we saw in NumPy how we were able to perform various numerical as well as arithmetic operations on our arrays. That was basically a data given to us in the form of arrays, right? So why exactly do we need pandas, or what is pandas? Alright, so in order to understand that, I am going to go ahead and show you guys an Excel sheet. So as you can see over here, I have some data. So once you guys get familiar with data analysis, you guys will be able to tell me that this is something known as house price prediction data set. But we need not get into the details of that right now. So for now, all you have to understand is that there are different features or different columns representing the features of a house, right? So we have the square feet, that is the area of the house. We have the city, we have the state, we have the condition, we have the waterfront, which basically is telling us whether there is a waterfront. So basically 0 and 1 is how our data is being represented. Okay. So the number of floors, the price, alright. So we have all these features in our data, alright. Now if I were to represent the same thing in a NumPy array, I would have my array something like this. Okay, so say I'm just representing two houses, and these two houses have two bedrooms, two bathrooms, okay, and the other house has just one bedroom and one bathroom. Okay, this is what my NumPy array would look like. Okay, this is basically my house 1, my house 2, and this is my bedrooms, and this is my bathrooms. Okay, so do you guys agree with me or not? would our NumPy array look something like this or not? Except we wouldn't have this information with us. We would just have an array that would look like this. So this is the major issue that comes in NumPy when we are dealing with data. Okay, so since we only have 2 columns over here, maybe we can try and remember that the first one is bedrooms, the second one is bathrooms. But in case we have 12 or say 50 columns, how are we going to remember what each and every column is representing? So this is where Pandas steps in. Pandas is nothing but a tabular format of data, just how we saw in Excel. It gives us a similar representation of data in our notebook. Alright, so before we go ahead and see the demonstration with Pandas, first we'll understand why Pandas. So here are some of the important features that Pandas provides us. So it gets very easy to import our data sets. It could be a CSV file, it could be an Excel sheet, okay? It could even be your SQL database. So you can import any sort of data set in your Pandas environment. I'll be using Google Colab in this video, but you can use Anaconda or even your VS Code. Alright. Then comes your data cleaning. So this is a very important step. Now what exactly does data cleaning mean? So when we say data cleaning, we are talking about missing values and majorly the invalid values. Okay. So when we talk about missing values, okay, let me go back to my Excel sheet. Okay, so this is the data that I have, right? So say in case of this particular value over here, 10500, what if I had a blank cell over here? That would represent my missing value. Okay, so that is basically what missing value means. So if we have a particular data set and some of the values in our data set are missing, so whenever we're dealing with that kind of scenario, we will be dealing with those missing values. Okay, we will be seeing how we can do that with Pandas. And the other case is invalid values. So say I have an age column. Okay, now we know our age can normally range from 0 to 100. Taking the worst case scenario over here, we have 100 or say 120. Okay, it cannot go above that and it cannot go below 0. Alright, so this is basically a standard age range. But what if I have a value say 200 in my age column? Now this is basically an invalid value, right? I cannot have an age that is 200 if it's for humans especially. Okay, so I would understand that there is some typing error or there is some mathematical error, and the common way of dealing with this invalid value would be dividing by 10, right? So 20 is a valid age, but 200 is not. Okay, so that is basically what invalid value means. Size mutability. So we can easily add and delete columns or rows. Okay, then we can reshape our data set, we can pivot our data set, we can efficiently manipulate and extract from our data set. And most important step is statistical analysis. Okay, so we can easily have all the statistical analysis of our data with just a few lines of code. Okay, now moving on to the prerequisites to learn Pandas. So you need to know any programming language, preferably Python. But if you know any other programming language as well, it's not an issue. Okay, and the next one is maths. That is basically you need to know some stats or inferential statistics. You need to have a basic idea like what is standard deviation, what is variance, what is mean, median, mode. So basically you need to have a basic idea of all those terms. So moving on to Pandas, we have two primary data structures in Pandas. First is series, second is data frame. Okay, now what is data structure? Data structure is basically a collection of data types that provide the best way of organizing the items or the values in terms of memory usage. Okay, so series is going to be our one-dimensional data structure, whereas data frame is a two-dimensional data structure. Okay, now series basically represents only a single column from the entire data set, whereas a data frame is able to represent the entire data set. Okay, that's the basic difference. So let's go ahead. Okay, so series we already discussed is one-dimensional. Why it's one-dimensional? Because a series would look something like this. So say I have a price column and these values would be represented by an index value by default. Okay, and remember our index is always and always going to start from 0. So this is our series. Okay, so over here you cannot say this is a two-dimensional or it has two columns. This is the index and this is our one and only column. Okay, so this is why series is a one-dimensional data structure, because it can accommodate only one column and you can extend it to as many rows as you want. Okay, so it is a one-dimensional labeled homogeneous array. Homogeneous array means it can accommodate only either integers or string values. Now, it's not that if I were to add, say, a string ABC, I would get an error. Rather, if I were to add a value like this, all of my integers would be converted to string. Okay, so this is why series is called a homogeneous array, because if I add a single string value into my series, all of my integers are going to be converted into string, and my data type of this series would be object. Okay, if I were to have only integers, my data type would be integers. Okay, so this is basically what it means. And very important property is it is size immutable. Now what this means is I cannot delete a particular row from here. I can only remove it, and when I perform the remove operation, basically I am going to be returned a new string. That is, my string originally is not going to get manipulated, rather I'm going to be returned a new string where my values would look something like this. Okay, so this is basically what size immutability means. And even if we try to append a new element, we would be again returning a new series rather than manipulating or rather than changing the original series itself. Okay, now moving on to data frames. It is a two-dimensional data frame because we can have multiple columns. So we can have a price column, we can have number of bedrooms, number of bathrooms, and so on. Okay, we can have unlimited, or you can say n number of columns and n number of rows. So basically it can be extended in this direction as well as this direction, whereas series was able to extend itself only in this direction. Okay, and this is going to be a size mutable tabular structure, and it can be heterogeneous type. Heterogeneous means we can have, say, integers in this column and a string, all the string values in this column. Okay, so we can have multiple data types supported in data frames, and it is size mutable means you're easily able to add and delete the rows and columns. Okay, so I hope the difference between series and data frame is clear. So let's go ahead and look at the implementation in our notebook. But before we do that, I hope you guys remember you are supposed to install pandas using pip install command. Let me just show you guys quickly. So you can go to your terminal or any command prompt, and all you have to do is type pip install pandas. When you run it, you're going to have a few lines of code run for you, and then finally you're going to get your requirement is satisfied, and then after that you can proceed with importing pandas as PD. Okay, so again, this is an alias. Just like we used an alias for NumPy, we are going to use one for pandas, which is PD. Okay, so I'm going to run it. And if you guys remember, I told you guys in the NumPy video that NumPy is going to be used throughout your data analysis process. So right now we are going to focus only on the pandas features, but when we come to real data sets, which I'll be showing you, I'll be importing a real data set also using a CSV or an Excel file, and then I'm going to show you how NumPy and pandas both are going to be used to perform various operations on that data set. Alright, but right now we are going to be only focusing on pandas, understand the features and the implementation. Okay, so as you can see, I have successfully imported my pandas, and the green tick over here basically represents that the operation was successful. Okay, so now what I'm going to do is I'm going to create a basic series using pd.series, and I'm going to do so using a list. Okay, now if I go ahead and print it, so you can see my data type is int64 because all of these are integers, and by default I got an index value of 0, 1, 2, 3 and 4. Okay, so as I told you, my index is always and always going to start from 0. And now if I were to add another element, say a string value ABC, you can see now my data type is object, and all of these that were integers earlier have been converted into a string form. Okay, so I am going to remove this for now because I want to show you guys some operations that we can perform in series. So I can go ahead and check the data type of my series. It's int64. Then I can go ahead and check the values of my series. Okay, so you do not need any parenthesis. So these are the values of my series data structure. So you can use s.index to check the index of your series. You can see over here my starting value is 0 and my stop value is 5 and my step value is 1. All right. So basically, I have my index from 0 to 4. So here you can get an idea about your index as well. Okay. And lastly, you have s dot name. So it's not printing anything because it's none. So if I print s dot name, you can see it's none because we have not given any sort of name or any sort of value to a column. Okay, in order to assign a value to our column, we can just say s dot name, and we can assign a value to our column, say those are just numbers. So I'm going to write numbers, and if I print my series, you can see this is what my series is going to look like. Alright. So that was it about the random functions. Now we're going to look at an important topic called indexing. Okay. So you can do indexing using square brackets like we normally do for lists, and we have also done for NumPy arrays. So similarly, you can do it for your series in pandas. So if I want the first element, I'm going to say S0 and I get the first element, that is 10. Okay. So if I want multiple elements, all I'm going to do is S0 to 2, and you can see my ending index or my ending value is not included in my output. So let me just comment it over here, and then we have the step value. So we have done this indexing in list as well, and you guys are well aware that your starting value is always included, whereas your ending value is never included. Alright, so whichever value you want at the end, you give your stop value plus 1 to your desired value you want in the end. Alright, so say I want values at index 2 and 3. My syntax for that would be S2 to 4. Okay, so as you can see over here, I got my values at index 2 and 3. Alright. Now another way to perform indexing is by using a function called ilog, which basically does location based indexing. So what this means is it is going to use the indexes, that is the 0, 1, 2, 3, 4 that you have as indexes, and it is going to fetch the values at those particular indexes for you. So all you have to do is say s.ilog and value at 3, and I print it, and you can see I got 40. So at index 3, I have value 40 and it's giving me the correct value. Okay. Now if I want multiple values, all I have to do is s.ilog and use double brackets and pass all the indexes that I want my values at. Okay. So I want value at index 1, 3 and 4. So as you can see, I got my output just as I intended. So this was all about location-based indexing. Now another important feature in series is that you can change the index according to you. Okay. So instead of 0, 1, 2, 3, 4, these numbers actually represent the calories. Okay. These are the different calories. So you can see I have changed the column name to calories. And now I want these calories to represent the fruit. Okay. So I'm going to create a list of all the fruits that are present in my carries. So you can see I've created a random list of fruits and I've stored it in the variable index. Now what I'm going to do is I'm going to say s.index and I'm going to pass my index variable, and then I'm going to print my series. So you can see over here, I am basically trying to say my apple has 10 calories, banana has 20 calories, grapes has 30 calories, and so on. Okay. So this is how you can change your indexes according to the information you are trying to represent. Now do not comment that I have put wrong calories for the wrong fruits. This is just a random data that I have created just to show you guys how indexing works. Okay. So now if I try to access any value using my indexes, so if I want to find the calorie of grapes, I can just say s grapes. Okay, in square brackets. Now can I use ilog function over here? Let's try it. Okay, so I get an error because this is not a location anymore, right? So when I had my numerical indexes, ilog was working absolutely fine. So I can still use ilog, but for my numerical indexes, right? The original indexes, that is, we have indexes in lists, we have indexes in NumPy, we similarly have indexes in series as well, okay? So we can do that by ilog, but again, how will we remember what is index 3, right? So that is why we have another function called log. This is label based indexing. Okay. So using log, we can go ahead and say, and you can see I get my value. Okay. Now another important thing you need to remember is in label based indexing, your start as well as stop value both are included in the output. Okay. Now this is a very important thing that you need to remember, because unlike normal indexing or the indexing that we do in list, numpys and all, whenever we're using a normal list, our stop value is never included. Alright. Now say I want my calories of banana, grapes and orange. Okay. So what I'm going to do over here, so you can see my banana, grapes and orange. So all three of them, that is my starting value as well as my ending value, both have been included. I hope label based indexing and location based indexing, that is your normal indexing, the difference between both of them is clear. Difference between lock and iLock is clear. Okay. So let me give you guys a quick recap. We learned how to create a series using a list. Okay, we saw the default indexes, we saw the default name, which is none of the column. Then we saw how to check the data type of the series, we saw how to check the values and the indexes of the series. Then we saw how to rename our column or the series. Okay, and then we went ahead and looked at indexing. We saw normal indexing, we saw indexing using iLock. Okay, then we went ahead and changed the index of our series. We gave a different set of indexes to our series using s.index equal to the new index. And then we went ahead and performed indexing on our labels. That is, we used the new indexes to index the values. And then we also looked at the label based indexing, that is using lock. Okay. Now, if I want to access multiple elements over here, multiple values, again, I have to give double brackets and I can say grapes and then I want apple and I can print it. So you can see I got my desired output. Okay. So that is all about indexing. Now let's also see how we can create a series using a dictionary. Okay. So I have already created a dictionary for you guys, which is basically fruit protein. So our keys are the fruits and our values are the proteins or the grams of protein stored in that particular fruit. Okay, so this is our dictionary. Now if I want to create a series out of this dictionary, all I have to do is say I'm going to name it S2 because this is my second series, and I'm going to say pd.series fruit protein and I'm going to print it. Okay, so you can see, and by default the name of our column over here that is representing the protein is 0. So I can go ahead and say name equal to protein. Let's run it. Now my series is giving us a complete information of what our data is representing. Okay, and you can see the data type over here is float. Okay, again you can go ahead and perform the similar kind of operations on this particular series. I will be sharing this notebook with you guys in the description below so you can download it and do the necessary operations that we saw in our earlier series, that is our series S. So all those operations can be performed on this particular series as well. So I want you guys to pause the video, download the notebook and perform these operations. And if you guys face any doubt, comment it in the chat box below. I will respond to you guys at the earliest possible. Okay? Alright, so I'm assuming now you guys are done with the earlier operations. Now we'll be looking at something important and something new, which is called conditional selection. Okay? Now what conditional selection basically means is, now I want to fetch all the fruits over here that have protein greater than 1. Okay. I want to find out all the proteins that are greater than 1. So what I'm going to do is, I'm going to say S2 greater than 1. Now you can see over here I've got boolean values that are representing true and false. So wherever I have protein greater than 1, I got a true. And wherever it is less than 1, I got a false. Okay. But what if I want only those rows in my output that have the value greater than 1? So what I'm going to do is I'm going to put this conditional selection statement inside my series. So I'm going to pass it inside my original series and you can see I got the result. Okay, so all these fruits have protein greater than 1. Okay, so this is basically how conditional selection works. It is first going to provide you with a mask series, which is basically a series of boolean values true and false. And if you pass that masked series into your original series using square brackets as we just did, you get your desired output. So our next topic is logical operators. Okay. Logical operators, we have and, or, and not. So I hope you guys are clear with what is and, or, not. Okay. If you guys are not, let me just give you guys a quick example. Okay. So say I have two values. One is true, the other is also true. Now if I do a and between these, if I perform an and operator between these, my result is also going to be true. Okay. Now, if I have a true and a false, and I perform an AND operation between these two values, my result is going to be false. Okay. Similarly, if I have a false first and a true later on, and I do an AND operation, my result is going to be false. And if both my values are false, my result is again going to be false. Okay. So, we need both our values to be true in order to have a result true. Okay. But in case of OR, any one of our value has to be true. This is going to be true. But if I have true or false, it is again going to be true. Okay. If I have false or false, then it is going to be false. Okay. So this is basically and or. Okay. Now let's see how it is used in a series. So say I want to give a range. Okay. I want to have all my fruits, or I want to see all those fruits which are greater than 0.5 but less than 2. Okay. So all I'm going to do is S greater than 0.5 and S is less than 2. So this is the syntax that you have to follow. Okay. So you can see I got the true and false values. Now if I want to find only those rows which satisfy this condition, so you can see all these values are going to be between 0.5 and 2. Okay. I can see I can say less than or equal to 2. And now I have my fruits which have the protein value equal to 2 as well. Okay. So this is how AND is performed. So basically what happened there is wherever we had 0.5 and greater but less than 2, this range was passed to us when we use the AND operator. Okay. Now if I were to use the OR operator in this particular scenario where I'm trying to find this range, would I get this desired output? No. For the OR operator, my first condition would be greater than 0.5. So I would get all my values that are greater than 0.5, and then my second condition would be less than 2. So I would get all the values which are less than 2. That means below 0.5 as well. Alright, so as you can see over here, I have 0.3 and I have 2.6 as well in my output. So this is basically telling me that I have used an OR operation over here. Okay. So similarly, you can use and OR, and you can also use your NOT operation. So I can say I want all my values which are not greater than 1. Okay. So you can see all these values are smaller than 1. Okay. So this is how the logical operators like AND, OR and NOT are performed. And then finally we have a topic of modifying the series. Okay. So say instead of my calorie of mango to be 0.8, I want it to be 2.8. So what I'm going to do is, just like a normal list, I'm going to go ahead and say S mango and I'm going to say 2.8. Okay, so it's run successfully. Now if I print my series, you can see my mango protein has been changed to 2.8. Okay, so this is how you can modify your series. Okay, at any particular index. You can change the value. You can also change the index, but you will have to pass your entire index again. Okay. So this was all about series. Now we are going to move ahead with data frames. So I hope series was clear. If you guys have any doubt, comment your doubts in the chat box below. I will respond to you guys as quickly as possible. And do make sure that you guys have this particular notebook downloaded in your systems and you guys are working with me side by side. So that's going to make the entire process more fun. Okay. So far you guys have gotten a basic understanding of series and we have already covered NumPy. So I have a question for you guys. So basically I have a series and I want you to find the answer of this particular query. Okay, so if I say s dot not null and I say I want a sum of all the values that are not null, I want you guys to quickly comment the answer in the chat box and tell me what's going to be the answer in if we run this particular query. Okay. So moving on, let's look at our very next topic, that is data frame. So it is important and very interesting if you guys understand it carefully. So basically I have some data in the form of dictionary, as you can see over here. So I have some names, I have some ages, and I have some departments and salaries. Okay, and now I want to convert this particular, so if I print this data, it's going to look like this. Okay, it's not very neat and it's not very easy to understand. So what we're going to do is we're going to go ahead and convert it into a data frame, and let me just print the data frame for you. Okay, all right, so I have this particular data set with me. So if I want to see just the starting values, I can just say df.head and say I want to see the first two rows. Okay, so I can do it using .head function. And if I want to see the last values, I can just say df.tail. Okay, so by default, the parameter over here is 5. But if we want, we can tailor it to our own needs. So I want to see the last three rows. So you can see 5, 4, and 3. Okay. So moving on, we can again use our log and ilog functions just like we did with our series. So say I want to fetch the first and second row of my data set. So what I'm going to do is I'm going to say df.ilog and I'm going to say 1 to 3. Okay. So you can see I have my first and second row and all the columns. Okay. So now in case of all these columns, what if I want only department and salary in my output? So what I'm going to do is I'm going to say df.log. So instead of ilog, I'm going to use log and I'm going to say rows 1, 2, 3 and I'm going to say I want columns age and department. So I'm going to have a comma over here to separate the columns. So you can see over here I have age and department and my 3 rows. Okay. So we discussed earlier, whenever we use the log function, our starting as well as ending indexes are going to be included. So I have 1, 2 and 3 rows instead of just 1 and 2. So if I want just the 2 rows, I have to say 1 and 2. Alright, so I hope this is clear. Okay, so we can use ilog and log in this manner. But if I wanted to include my first and second column in my ilog column itself, so you can see I have my first 2 columns in my output. Okay, so basically when we're using ilog for data frames, we have to pass our rows and our columns, and the range for these are going to be separated by a column. Okay, so we can do that using ilog and log. So we'll be using this a lot. Okay, direct indexing in a data frame gets a little complicated, so that's why we'll be only using ilog and log functions. Okay, so you can go ahead and play around a little with ilog and log and try to access different rows and different columns. So now we'll be moving to accessing only an individual column. Okay, now if I want to access just one particular column, all I can do is say df_age. So this is how I get only the age column. Okay, now if I want multiple columns, I have to add another bracket and I can simply separate my columns and say I want age and department. So you can see this is how I get my output. Okay, now what if I want to drop this age column? Okay, so you can see I have a null value also over here. Now I want to drop this age column because I feel it's not very relevant to my data set. So how I can drop it is I will just say df.drop and I will say age. Okay, and I will pass axis equal to 1 because I want this entire column to be gone. Okay, if I want a particular row to be gone, my axis would be 0. Okay, so it is a particular row wise operation. But if I want a column gone, I want my axis to be 1. Okay, so if I run it, now you can see my age has been disappeared from this particular output. But if I print my data frame, you can see the age is still there. Okay, so until and unless we use the parameter in place equal to true, by default in place is equal to false. Okay, so in place is basically telling us to perform the operation in the original data frame. Okay, so if we want the changes to be displayed in our original data frame, we are going to use in place equal to true. Otherwise, by default, it is going to be false and it is only going to return a new data frame and our original data frame is going to remain unchanged. Okay, so as you can see, it has been unchanged. Now this is a missing value over here, this and this. So we'll be dealing with these missing values later on. But first, let's understand a few more functions. So we can go ahead and check the shape of our data set using df.shape. So this is telling us that we have 6 rows and 4 columns. Okay, 1, 2, 3 and 4. Okay, so again the indexes are not counted as a part of a column just like we did in series. Okay, so these are by default values over here. And we have 6 rows. Okay, so we basically have 6 samples. Okay, these are known as samples. This is the sample sets. Okay, so we can also go ahead and check the data type of our data frame. So we can also go ahead and check other information about our data set. So using info. Okay, so this is telling us that we have these particular columns: name, age, department, and salary. Okay, and these are the data types in our column. So we have 2 columns having float data type and 2 columns having object data type. Okay, so name has object data type, age has float data type, department has again object data type, and salary has float data type. Okay. Now over here we have a non-null count. Non-null count basically means that we have 6 non-null values. That is, we have total 6 samples and all of these 6 samples are non-null. Okay. So basically in the name column we have 0 null values. Okay. And we move to the age column, and over here we have 5 non-null values. That means we have 1 null value over here, and over here also we have 1 null value, whereas over here we have 0 null values. Okay, it is also displaying the memory usage to store this particular data set. Okay, and another operation that you can perform on your data set is describe your data set. So over here you get statistical information on your data. So over here we only have 2 data sets that are of type float or integer. Okay, so we can perform these particular operations, that is the count, mean, standard deviation, minimum value, and these 25%, 50%, 75% are basically the outliers in our data set. Okay, and the maximum value. Okay, so using the describe function you get a basic information about your data, like you have 5 values in your age column and 5 values in your salary column that are present. Then the mean value of your age column is 28, whereas mean value of your salary column is 58400. Standard deviation is this. The minimum value of age is 25 and minimum salary is 50,000. Then you have other information about your data set. Okay. So in NumPy, we saw an important concept called broadcasting. Okay, we also looked at the rules for broadcasting. Now we'll see how broadcasting is performed in Pandas. Okay, so I have a salary feature over here. So our columns are also known as features. Okay, so these are our columns or our features. Okay, so if I want to say increase the salary of all the people over here, okay, of all these people, I want to increase the salary by say 5,000. All I have to do is say df salary, and I will say df salary plus 5,000. Okay. Now you guys must be wondering, this is a scalar digit or an integer, whereas this is a one-dimensional array, right? If I just print df.salary, let me go ahead and print df salary. If I print this, you can see this is a one-dimensional array, right? This is basically an array having 5 rows and 1 column, right? And this over here is just a scalar value. Now I want to increase all these values by 5,000. So do you think if I perform this particular operation, I will get an error or will it successfully perform? So if you guys said it will successfully perform, you guys have understood broadcasting really well. So if I go ahead and print my salary now, so you can see it has been increased by 5,000. Okay. So what's happening over here is, instead of treating this as a scalar value, it has been broadcasted to match the shape and size of this particular column. Okay. And then the operation has been performed over here. Cool. So moving on to the next concept, we have renaming columns. That is, we can rename the columns in our data. Okay. So if I want to rename a column, all I have to do is call df.rename and pass my columns. Okay, so I want my department column to be displayed as DEPT. Okay, and I'm going to say in place equal to true because I want this operation to be performed in my original data set itself. Okay, so if I go ahead and print my data, so you can see my department has been changed to DEPT. Okay, so this is how you can go ahead and rename your columns using .rename function. So you can also go ahead and check the unique values in your data for a particular column. So I want to see all the unique salaries in my data set. So you can see over here, these are the unique salaries in my data set. Okay, I can check it for another column. So I can check the unique departments. So again, these are case sensitive. So if I check the unique departments in my data set, so I have 3 unique departments, that is HR, IT and finance. Okay. Now, if I want to see how many employees are in which department, I can go ahead and do the value count of these departments. So I will say DPT dot value counts. Now, as you can see over here, HR department has 3 counts, IT has 2 counts, and finance has 1 count. Okay, so basically it's telling us that there are 3 people in HR team, 2 people in IT team, and 1 in finance team. Okay, so this is how you can check the distribution of one particular column across your data set using value counts. Now, what if I want to create a new column called promoted salary? That is, I want to check the salary of all the employees after the promotion. Okay, so say some of my employees have been promoted and I want to create a promoted salary column in my data set itself. So if I want to do that, all I have to do is say DF original salary, and after the promotion their salary is going to be, say, multiplied by 10. Okay, so if I run this particular query and then print my data set, sorry, my data frame, so you can see the salaries have been increased in my promoted salary column. Okay, so they have been multiplied by 10. Again, this is a broadcasting rule again. Okay, so this is how you can go ahead and create a new column in your data set or your data frame. Alright, so now that we have learned how to create a new column, I think it's time to dive into data cleaning. So as you can see, we have a few null values in our data set. So I want to get rid of them because till I have those, I will not be able to perform some operations, plus it doesn't look very good. Okay, so first I'm going to check how many null values exactly I have. So all I did was I checked for my null values inside the entire data set, and then I did a sum of all those values. So as you can see over here, my name column has 0 null values, my age column has 1 null value, and my salary column also has 1 null value. And so does my promoted salary column. Okay. So I have a few options over here. I can either just get rid of all the rows that have these null values. Okay. So I can do that by using df.drop na. Na stands for null values. So I'm basically dropping all the null values, and if I just run this prompt, if I just run this without any sort of argument or without any sort of parameter, as you can see, I'm just left with 4 rows. Okay, so basically any row that had null value has been removed. And again, I have not used in place equal to true, so my original data set is still untouched. Okay, so this is basically just a new sort of data set that has been altered and returned so that I can see how it's going to look. Alright, so by default over here, you can see my argument of how I want my null values to be deleted or dropped is any. So basically any row that has any sort of null value has been dropped. Okay, so if I run this using how equal to any, so again my result is the same. So we saw one sort of parameter in drop NA, that is how equal to any. Now the other parameter in drop NA is all. Okay. Now the other argument that drop NA takes is all. Now what this is representing over here is particular row. Okay. When we said how equal to any, we were just saying any row that had any null value. Okay. So whichever row had any null value was dropped. Now over here we are saying if all the values in a row are null, we are going to drop that row, otherwise we are not going to touch it. Okay, so we do not have any row that has all the null values, we just have this row that has 2 null values, but again we have 3 non-null values as well in this particular row. So again, none of my rows were altered and the data remains as it is. Okay. So this is one option when we are dealing with missing values. We can just get rid of those null values. Okay. The other way is to fill those missing values. Now how I can do that? So let me just find, okay, here is my null value, right? So I can either fill this null value with the most repeated value in this particular column. Okay, that is one option. Let me just write it down for you guys. Okay, so dealing with missing values is one of the most important aspects when it comes to a data set, because you will be dealing with a lot of unclean and messy data sets, and missing values is going to be one of them. Okay, so let me just write missing values. So one way of dealing with missing values is getting rid of them, which we just saw by using drop NA. Okay, and the next one is by filling them up. And for filling those missing values, we use the function fill NA. Okay, so this is the second method. Let us see how it works. Okay, so all I have to do is say df.fill_NA. Okay, and let me just run it. So I must specify a fill value or a method. Now I want to fill all the null values with say 0. So you can see this is what my data set is going to look like finally. Okay, but this is again a very noob method to perform on a data set, because I do not want my age to be 0 or my salary to be 0 just because it's missing, right? So instead what I can do is, for my age column, I am going to fill all my missing values with the mean. Okay, and I'm going to say, okay, let's not keep it in place equal to true, because I do not want to modify my original data. But if you guys want to, you guys are free to do it. Okay, so I'm just going to replace all my missing values in the age column with the mean of the age. Okay, so initially my third row had a missing value, and now it has been replaced with the mean. All right, similarly for the salary column, what I'm going to do is, if I replace it with the mean, it's not going to be very technically or mathematically correct. So instead what I can do is, I can replace it with the median, right? I can go ahead and replace my salary in my df column, and I'm going to say I want it to be filled with the median of my salary. So you can see over here, my fourth row was missing in my salary column, and now it has been filled with the median value. Okay, so this is another way that you can fill your missing value. Okay, now this is something that we can do mathematically, right? But what if I want to just randomly fill my value? So this was the missing value, right? So there is another method in fill NA. Instead of providing a default value, what we can do is something known as forward fill. So basically when we use fill NA, we have two methods, forward fill and backward fill. So in forward fill, what happens is we move from top to bottom, okay, and say this was our missing value. So when we use forward fill, 35 is going to be replaced in our missing value. Okay, and similarly when we do backward fill, 29 is going to be replaced for our missing value. Okay, so this is basically what forward fill and backward fill means. So let us quickly go and perform forward fill first. Dot fill NA, and in our method we're just going to pass forward fill. Let's run it. So you can see 35 has been replaced in our missing value column. Okay, so it has been done using forward fill. Similarly, I can perform a backward fill. So you can see 29 has been replaced in my missing column. Okay, now using these methods, backward fill and forward fill, can be a little tricky, and they can also give you errors in cases where your first or last value is null. Okay, so in case your first value is null and you try to do a forward fill, your first value will still remain null. Alright, and same goes for backward fill. If your last value is null and you do a backward fill, your last value will still remain null, because there won't be any value before that to replace it with. Alright, so in cases like that, we go for statistical operations like mean, median, mode, alright, according to what's more technically sound. Okay, so these are some of the methods to deal with your missing values. Okay, so now we saw how we can deal with missing values. Now we'll look at another operation where we can say replace a particular value randomly. Okay, so say instead of Charlie over here, I want to replace this name with another name. So now, just because we did not use in place equal to true throughout our queries when we were dealing with our missing data, does not mean we have not already dealt with them. We have already dealt with our missing data, and currently we shouldn't have any sort of missing values in our data set. Okay. So moving on, I want to just randomly replace this particular name, say with Rose. Okay, so I want instead of Charlie, I want Rose in my name column. At I just have to say df dot replace. Okay, df in the name column. Okay, I have to specify the name. Sorry, I have to specify the column, and I have to say replace Charlie with Rose. Okay. So as you can see, my operation has been performed successfully. Okay. And again, if I wanted this change to be reflected in my original data set, I would have to say df name, and I would basically be storing the change in my original data set. And now I can go ahead and run it. So as you can see, I have changed the name from Charlie to Rose in my original data set as well. Okay. So this is how you can make your changes permanent. Okay. All right. So let's look at the next concept when we're cleaning our data, that is dealing with duplicate data. Okay, so we already saw how we deal with missing values. Now we will see how we deal with duplicate values. Okay, so as you can see in this particular data set that we have over here, we have the entry Alice twice. Okay, and as you can see, the age, department salary, and the promoted salary, they match for both these records. Correct? So how do we deal with duplicate values? So we already have an inbuilt duplicated function. So in order to check for all the duplicate values, all you have to do is say df.duplicated and pass it in the data frame variable. And when you run it, and your output will be your second repeated record in your data set. Right? So we are not going to consider this as duplicate. Rather, we're going to consider this as duplicate. So let's see how duplicated works. Okay, so say I have a record over here of different countries. Okay, so I have Italy, France, Greece, and then Italy again. Okay, so if I go for duplicated method, what happens is we work our way from the top itself to the bottom. Okay, so first I'm going to check for Italy. So Italy is not present. No problem. I'm going to simply add it to my list, or uh, a list where basically I'm keeping a track whether an element is duplicate or not. Right. Then comes France. So it's not there. No problem. I add it to my list. Then we come across Greece. No problem. I add it to my list. Then I come across Italy, which is already present in my list. So therefore, this element is going to be marked as duplicate. Alright. So this is basically how the duplicated method works by default. Alright. So basically we can pass a parameter called keep, and we are going to say keep first. Okay. So let's see what happens now. So you can see our first element is not going to be marked as duplicate. So this is basically by default the parameter that duplicated takes. Okay. If I say last instead of first, you can see my first element is marked as duplicate. Okay. So when we say keep last, basically we are going to work our way from bottom to up. Okay. So that's why this element is going to be marked as duplicate. All right. So I hope this is clear. So if we want to drop this duplicate value, all I have to do is, okay, so I'm not going to pass anything because I would prefer my second record to be deleted. So I'm just going to run it. So if I print my data set, you can see my duplicated record, that was the second record, has been removed or deleted from my data set. All right. Okay. So I hope the data cleaning process is clear. We have learned how to deal with missing values as well as duplicate values. Okay. All right. So let's see how we can deal with invalid values. Okay. So since I want to make the changes in my promoted salary column, I have simply written df and promoted salary in the brackets. And now in order to do these changes in the column of a particular data set, I will be introducing you guys to a very important topic or an important function called lambda. So you guys must have studied this in Python as well, right? So all we have to do is promoted salary, and I will say apply lambda x, and I'm going to say divide that x. X is nothing but the records of my column promoted salary. So this is my input variable x, and this is my output variable x divided by 10. But I have a condition. If x is greater than 6,50,000, right? Else, if it is not greater than 6,50,000, I'm simply going to return x. All right. So let me run it. Okay, so it has run successfully. I'm getting some sort of documentation, but I'm going to ignore it for now. Okay. So as you can see, the two records that I had that were greater than 6,50,000 have been divided by 10. Alright. So this is how you can deal with your invalid values using the lambda and apply function. Alright. So this is the syntax for that. So moving on, we'll also look at some string functions. So in this particular sample dataset that I have taken, we do not have any sort of explicit need to do these string functions. Okay, so maximum times whenever you have a string input, okay, so say the names. Over here, I just have the first name, but in case I had a name like Alice underscore, say, Fernandez, okay. So in order to deal with inputs like this, all I would have to do was df, and I would create two separate columns saying first name and last name, okay. And then all I would do was df, and I would split my name column. So basically I'm using name as this name instead of my column name, because I do not have any sort of input like this which I want to demonstrate to you guys. Okay, so even though this is not a column per se, this is just a variable that I've created, and I'm pretty sure I'm going to get an error. Okay, so I am going to split it using string dot split method. Okay, and I want to split it based on underscore. Okay, so whenever I have an underscore, I want to split my string. Okay, so in case instead of underscore all I had was a space, I could use an empty string over here. Okay, but since I have an underscore between my first string and my second string, I'm going to split it based on my underscore. Okay, and let me see if I run it, what's going to happen. Okay, so I do not have any column name, but again, this is how you would split your data set. So obviously this code is not going to run for me because I do not have any column called name, and wherever I have name, I do not have any sort of connectors between two strings. These are just single names. Alright, so I will not be able to split these particular strings over here that I have. So this is just a demo for you guys, that in case you have a column like this is how you're supposed to deal with it using string.split method. Alright. So now that we are clear with data cleaning, I want to show you guys a few more examples of apply and lambda. Okay, so because there will be instances where these methods are going to be very useful because they let you change the single entries of a column or a row, right, based on particular conditions. All right, so let me create another scenario where I want to multiply the age. Okay, I want to multiply all the ages by 2. Okay, so all I'm going to do is age, and then I'm going to call my age function or age column over here, and then I'm going to say I want to apply. Now instead of passing lambda, what I can do is I can go ahead and create a function where I am multiplying my age. Okay, I'm going to have my input as x, and then I'm going to simply return x into 2. Okay, so instead of calling lambda over here, what I can do is I can say multiplying age and pass x. Okay, so it will not take any input. I'm sorry about that. So let me run it. Okay, so now if I print my data frame, you can see my values of age have been multiplied by 2. Okay, so let me bring back my ages to the original value. Now this time I will use lambda instead of creating a function by default. Okay, and I'm going to say apply, and I'm going to pass lambda, and I will say x, and I will say x divide by 2. Okay, now there are no conditions, there are no if else conditions. I want all of these entries in the age column to be divided by 2, so I'm not going to pass any if else like we did previously, right? So I'm going to run it, and if I print my data frame, my ages are back to the original values. Okay, so this is how lambda and apply functions are used, and you will be using them quite a lot. Okay, So moving on, I want to tell you guys about another very important concept, that is joins and merges. Okay. Now, in order to understand joins, let us go through a quick overview of what are joins. Okay. So consider this scenario where I have two data sets, A and B. Okay. Now, when you're dealing with large data sets, it's not necessarily that you're going to have all the columns in one particular data set. Okay. So, if you guys remember, I showed you guys an Excel sheet of various columns or various features of a house, right? Number of balconies, number of bedrooms, the location, the state, and so on, right? Now I had all those columns in one particular sheet. But what if I had two sheets, A and B, where in one sheet I only had, say, the features of the house, that is, the number of bedrooms, the number of bathrooms, the balconies, and in another sheet I had the different features, say, when the house was built, where it's located, what's there nearby, and stuff like that. Okay, so I had two separate sheets. Now I want to combine these sheets, all right? So there are different methods. So if we talk about joins, there is left join, right join, outer join, and inner join. Okay, these are the joins that exist. And another method is to merge. Okay, merge is similar to inner join. All right. So let's quickly see what left join would look like. So if we were to combine these two data sets on, say, a particular property, and we perform a left join, our left side of the data set, okay, whatever there is common between the two data sets is going to be ignored. Whatever exists in only data set B is going to be ignored. Rather, we are going to have something that is solely available with data set A, and this happens in left join. Okay. Similarly, in right join, it happens the opposite way. We're going to have only the properties of B in our data set. Okay. And when we perform a full outer join, we're going to have everything of A and B. Okay. So each and everything that we have in A and B is going to be included in our outer data set. Sorry, outer join. And when we perform an inner join, it basically happens over here. Okay. Only the common properties between A and B. And when we merge two data sets, we merge them based on this particular common column, and whatever properties A and B have, both are visible in our merged data set. Okay, so let me say this is another data set. So let me just convert it into a data frame. So I'm going to call it df2, and I will say pd dot data frame, and I will pass my department. Okay, so let me just print my other data frame. So as you can see, this is my second data set. So now if I want to combine the information from this data set and the data set that I had earlier, I have something known as concat. Okay, so concat is going to let me merge the information from both these data sets. So if I use pd.concat and pass the two data sets that I have, this is the output that I'm going to get. Okay, so since in our second data set we have a location and manager, but we do not know which employees have this location and this manager, we have a null over here. Okay, so by default both my data sets are being combined in a horizontal manner, that is, they are being stacked horizontally, right? So wherever I don't have the names, I am getting null, and wherever I don't have the location and manager information, I'm getting a null. Okay, but if I were to do the same operation column wise, that is, if I were to combine these two data sets in this particular direction, I would have to say pd.concat, pass my two data sets df and df2, and I would say I want it to be joined on axis 1. So as you can see over here, wherever I have department HR, my location and manager is for the department HR, right? So this is how you can combine or merge two data sets using pd.concat. Okay, there is another function called pd.merge. Okay, so you can pass your data sets df, df2, and I want it to be merged on my column department, because that is the common column. So as you can see over here, my department is being repeated twice. But if I do not want that to happen, I can use merge, and as you can see over here, my department column appears only once, and my data is managed accordingly. So wherever I have HR department, I'm going to have my location as New York and manager is going to be Laura. Okay, it is, you can see it over here as well, New York and Laura. All right, so this is also how you can merge or combine your two data sets into one. Okay. So these were basically all the operations that were there to know on data sets. The basic operations, obviously, as you go down the line, you deal with bigger data sets, your operations get more complex, but this is the standard basic base that you require to get started with Pandas. All right, so now we're going to look at how we can import a complete data set file, that is an Excel or a CSV file, in our notebook. So since I'm using a Google Colab notebook, I cannot directly pass the entire path of my file or my CSV or Excel sheet. If you're using Anaconda or VS Code, you can do that. So if you're using those platforms, all you have to do is right click on your data set and click on copy as path and create a variable and just say pd.read underscore CSV, because this is a CSV file, and all you have to do is pass the path inside the parenthesis as an argument. All right, but since this is a virtual environment and it is not going to be able to access my local environment, what I have to do is I have to upload my data on Google Colab. Okay, so I'm simply going to select it. So as you can see, it's uploaded over here. Okay, so now all I have to do is, in quotes, I have to say data.csv. So you can see it's run successfully, and now I can do data.head. That is, I'm trying to get the first 5 rows of my data set. So you can see this is the date, price, bedrooms, bathrooms. So I can easily access all the columns, and I can go ahead and perform the basic operations, like I can check the shape of my data set using data.shape. So I have 4,600 rows and 18 columns. All right. So accessing such information in an Excel sheet would have been a much more difficult task. So this is why we use Pandas, which helps us gather information like this in a much more efficient and easy manner. All right. So I can also go ahead and check the information of my data using data.info. So you can see I have 4,600 non-null values. That means I have 0 null values in my entire data set. I have 0 null values. Okay. So you can also check the data type of each and every column. Now you can see over here, this is an object data type, but date is supposed to be in a time format, right? You're supposed to be able to access the day, time, and year of a particular date in an efficient manner, but this is stored in an object manner. All right. So I'm just going to quickly show you guys how you can convert this date time from an object to a time. Okay, so this is the syntax that you have to follow. So I'm going to pass my date, and then I'm going to use pt.datetime to convert my date from object to, okay, so it is data. Okay, so as you can see, it has been executed successfully. Now if I go ahead and check my information of the data, you can see it is converted to date time format. All right, so this is how you can convert your date time features into the valid format using Pandas. All right, so this is again only a one line code, but you should be aware that it can be done, and this is how you bring your data to the correct format. All right, I think we have covered almost everything there is to know about Pandas, and I'm sure you guys got a basic understanding of how you guys can implement Pandas on even a large data set. And I am going to give you guys this notebook link in the description, so you can go ahead and download it and practice on this data set, or you can download data sets from Kaggle. Let me show you guys the website. So you can go ahead and type Kaggle and click on the first link that you get. Register on this website and you get hundreds and thousands of data sets for absolutely free. You can download them, and you can also go ahead and check out the discussions if you face any issues or doubt, right? So get started with your Pandas journey right away.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with iHub IIT Roorkee. Through this course, you'll get to learn data analytics from industry experts and IIT faculty in depth. You'll learn tools like Excel, SQL, Power BI, Python, and K9. This data analytics course is praised by our learners, and their user testimonials are available on our Intellipaat Achievers channel. You can check them out. The link is available in the description below. So, if you are really interested in learning data analytics, this is your opportunity. Click on that apply now button right away and get started in your data analytics career journey.
In this section, I'm going to walk you through the basics of visualizing data using one of the most popular Python libraries out there, Matplotlib. And something important that I'll be discussing, which is often neglected while learning Matplotlib, is how to choose the right type of graph based on the kind of data you have. Not just that, we will also see how to read these plots and make sense out of them. But before we jump into it, let's take a moment to understand what data visualization actually means and why it matters. Data visualization is all about turning raw data into visuals using things like charts, graphs, or maps. These visuals help us quickly see patterns, spot anything unusual, and just get a better sense of what the data is telling us. Here's a quick example. Let's say you have a list of sales numbers for each month of the year. Sure, you could look at those numbers one by one, but if you plot them on a line chart, you'll instantly see how sales went up or down over time. That's the beauty of data visualization. It helps make data clear, simple, and easy to understand. Now coming back to Matplotlib, this is a Python library built specifically for creating visualizations. It's been around for a long time and is widely used in areas like data science, research engineering, statistics, and business management. What makes Matplotlib so powerful is its flexibility. You can create all kinds of plots like line charts, bar graphs, scatter plots, histograms, pie charts, and even 3D plots. And the best part is you can fully customize how your plots look, from colors and styles to labels, titles, and legends. When it comes to using Matplotlib, there are two main ways to make your plots. The first one is through something called the PyPlot API. This is the simpler and more commonly used method. You just import it using import matplotlib.pyplot as PLT and then use functions like plt.plot or plt.bar to make your charts. The second way is through the object-oriented API. This one gives you more control and is better suited for complex or customized visualizations, especially when you're building something that needs to be more advanced or integrated into an application. In this tutorial, we are going to explore both methods using easy examples. So go ahead and open your Jupyter Notebook or Google Colab and let's get started with Matplotlib and the world of data visualization. So before we get started with the implementation of Matplotlib, I want to quickly show you guys the anatomy of a Matplotlib figure. So a figure in Matplotlib is basically the entire window or page. It's basically the entire canvas that represents the various components like legends, your axes, the grids, your labels, everything, right? So all the components are contained inside a figure. So let us quickly go ahead and see what are these different components. So first we have the axis. So we have x-axis and the y-axis, and what these axes are representing is basically shown by the labels. So we have x-axis label and y-axis label. So say for example, I have the data of number of hours studied versus the marks scored. So I can represent my x-axis as the number of hours studied and I can label it as number of hours studied, and similarly I can do it for y-axis label as the marks scored. So I know what I am showing on my plot. Then there's something known as ticks. So we have major ticks and minor tick labels. So major tick labels are basically these marks that you can see on your axis. So 0, 1, 2, 3, 4 are basically your major tick labels, and your minor tick labels are the in-between marks like 0.25, 0.5 and so on. And then we have something known as a legend. So this basically represents what each color or mark is representing. Right, so over here we have a blue line and a red line. So whatever these blue lines and red lines are representing, that can be shown in a legend. Then you have your grids. So these are the dotted lines that help you figure out or read your plots in a more efficient manner. Then you can also label your entire figure. So you can give a title to your figure using the title component. So that is pretty much it about a figure. So these are basically the major components inside your figure. As we go ahead, we will see how to tweak these different components according to how we want our figure to look like. Alright, so in order to get started, I want you guys to quickly open any terminal and just run the command pip install matplotlib. And once you run it, you will see a few lines of code run over here for you. And finally, when you get the message requirement satisfied, that means your library is installed successfully. Now, once your library is installed, you can go ahead and import it in any environment that you like. I'm using Google Colab. You can use VS Code or Jupyter Notebook, right? According to your preference. So I'm going to go ahead and import my Matplotlib if I run it. So it's imported successfully. So along with my Matplotlib, I'm also going to import pandas. And if I run it, so both my libraries are imported successfully. So just to give you guys a basic gist of what Matplotlib does, I'm just going to create two variables for you guys. So I have my variable x as 1, 2, 3 and my variable y as 4, 5 and 6. Okay, so these are my x and y variables. Now, in order to plot these variables using Matplotlib, all I have to do is say plt.plot, pass my variables x, y, and just say plt.show. And as you can see over here, this is what Matplotlib gives me. So over here, what Matplotlib is trying to do is, it is trying to plot my data like this. So 1, 4, then I have 2, 5, and then I have 3, 6. Okay, so these are the variables that I passed, and this is the data that Matplotlib is trying to plot over here. Okay, so if you go ahead and see 1, 4, 2, 5, and 3, 6. So if I want those dotted grid lines that we initially discussed in our figure, all I have to do is say plt dot grid and run it. So now you can see I have my grid lines. Now it gets much easier to read my data in a more efficient manner. Now I can easily spot that this particular dot represents 2, 5 and this particular spot represents 1.75, 4.75. So now you're easily able to figure out what each of these points on this particular line represent. Right? So this is basically the major idea or the major implementation of Matplotlib. Now using this functionality of Matplotlib, we are going to try and plot different kind of plots for different data sets. So as we discussed earlier, Matplotlib has two types of plotting. So one is using the PyPlot API and one is using object-oriented API. So first we're going to cover the PyPlot API. So let me just write it down that we are only going to discuss PyPlot API right now. In the end of the video, I'm going to discuss how you can use object-oriented API as well. Okay. So in order to understand which particular plot is to be used for what kind of data, let me quickly introduce you guys to univariate analysis. So a univariate variable basically focuses on one variable at a time. It could be a height, weight, or a category like yes or no. Alright, so first we're going to cover the numerical column. So in order to understand, let me just create a data where I have a column salary and it looks something like this. Okay. So this is my salary column and this is just a dictionary and I have to convert it into a data frame. So I'm going to call my dataset df and I'm going to say pd dot data frame and I'm simply going to pass my data. Now if I try and print the first 5 records of my dataset, this is what it's going to look like. Okay, so this is my salary column and these are my records. Let me also go ahead and check the total number of records in my data. So all I have to do is say df.shape and if I run it, so I have 20 records and I have only one column. So over here I have 20, 1. Alright. So now in order to visualize this particular column in my data frame, the first plot that I have is a line plot that we have already seen, but now we're going to see it in much more detail. So in order to plot a line plot, all I have to do is plt.plot. And in my parentheses, I just have to pass my column inside my df variable, that is my data frame, like this. So if I run it, so this is basically how my salary column is varying. Okay. So at some point it is really high, that is the highest salary is going to 55,000, whereas the lowest salary is somewhere around 25,000. Okay. Now what I can do is I can also go ahead and make some changes in my plot. Like I can say I want my color to be red and I want my grids to be shown, and I can also have my markers. So I can have my marker as letter O. Now what this marker is going to do is wherever I have a data point, it is going to be marked. So for example, over here, basically wherever I have a data point, it's going to be marked with the letter O. I can also go ahead and change the line width. Let me just run it. So as you can see, my color has been changed to red. I have grids in my plot and my marker is being represented with a dot over here, as you can see. Now instead of a straight line, I can change my line style to a dashed line like this. So now you can see my line is a dashed line, or I can also change it to a dot using the colon. So now you can see my line has been dotted. I can also go ahead and change the width of my line using the line width parameter, and I can say I want it to be 2. Okay, so as you can see, the width has been increased. So if in case I want my marker to be represented with a star, all I have to do is pass this particular symbol and you can see the marker style has been changed. Okay, so you can go ahead and play around a little with the parameters that are available in Matplotlib. Again, Seaborn offers a bit more functionality compared to Matplotlib, but this is great when you want to deal with your plots at a lower level. Okay. Then the next way we can visualize our column is through a histogram. So in order to plot your histogram, all you have to do is say plt.hist and pass your column in the parenthesis. And for now, I'm going to exclude the bins parameter and just show you guys how the salary column is going to look like in a histogram. Alright, so histogram basically tells us the frequency of our data distribution. So what this graph is basically telling us is that there are around 3 people that have the salary in the range 25,000 to 30,000. Then 2 people have the salary in the range 30,000 to 35,000. And there are 3 people again in 35 to 40 range. Okay, so this is basically how our data is being distributed. Now, in order to make it more clear, I can go ahead and pass bins, and I'm going to, no, I don't want grids for this particular graph, and I'm going to say my color is going to be green. So now I have divided my plot in 5 bins. So now it's more clear and more readable. Okay, so I have 6 people earning 25,000, then 5 people earning 30,000, then 3 people earning 35,000 and so on. Okay, so this is how you can read your data through a histogram. Then the next plot that we have is a box plot. So in order to plot a box plot, all you have to do is say plt.boxplot and pass your column over here and simply say plt.show, and this is what your box plot is going to look like. Okay, so whoever is not clear with what a box plot is exactly, let us quickly understand it with the help of this image. So a box plot has 2 endpoints. One represents the minimum value and one represents the maximum value. Then there's a line that is connecting the minimum value to the lower quartile, and it's called the whisker. Now your lower quartile is known as Q1, which basically represents 25 percentile. So basically 25% of the data is below this particular point. Okay, then you have your mean value and your median. Median is also known as Q2 and it's the 50th percentile. This represents 50% of the data is below this particular point. Then you have Q3, which is 75 percentile. So 75% of the data is below this particular point, and then you have your maximum value. Okay, so Q1 to Q3 is known as your interquartile range. And then you have something known as outliers. Now, outliers are basically the extreme values that are either lower than the minimum value or greater than the maximum value. Okay, so these are basically the extreme values and they are plotted outside the box plot. So, box plot makes it very easier to identify whether there are any outliers in your data or not. Okay, so as we can see in this particular plot over here, there are no outliers currently. But if I were to add a salary, so at index 20, I'm basically adding a salary 0. Okay. Now, if I run it, now I go ahead and plot a box plot. You can see over here, I got an outlier value which is at 0. So this is the value I just inserted, as you can see over here, through df.loc. So we have already covered LOC and ilog in my previous video of Pandas full course. If you guys have not watched it or you guys do not understand how I have added a new record in my dataset, I suggest you guys to quickly go ahead and watch that video before you continue with this video, because we will be using pandas somewhere or the other throughout this video. Alright. So as you can see, I've got my outlier value over here, which is really far away from my entire box plot. So it's suggesting that whatever range my other salaries are in, this particular salary does not match that range. Okay. So I can simply go ahead and remove this value from my dataset in order to avoid any bias in my entire calculation when I'm going ahead with prediction models and all. Okay. So I'm just going to go ahead and remove this value. Okay. So I'm back to my original dataset. Now, this was all about when you have a single numerical column. All right. So, salary was something that contained all numerical values. But what if I had a column that had all categorical values? So, now we're going to deal with a univariate categorical column. Okay. So, in order to deal with a categorical column, let me just quickly go ahead and add another column to my dataset called department. So now let me go ahead and check my data frame, what it looks like. So as you can see over here, I have a salary column and a department column. And my department column is a categorical column. I can also go ahead and check that using the info parameter. So you can see this is of type integer and this is of type object. So basically, all of the data that I have in my department column is of type string. Alright. Now if I want to visualize this particular column, I cannot use a line chart or a histogram or even a box plot because those are used for a numerical column. So in order to visualize this column, I'm going to use something known as a pie chart. Now, in order to plot a pie chart, what I have to do is I have to create a count variable where I am simply going to count the number of unique values in my department. So this is what it's going to look like. So I have 8 HR departments, 6 IT and 6 finance departments. Okay. Now I can go ahead and plot this data in my pie chart using plt.py. Simply pass my count variable, and if I print plt.show, this is what it looks like. Now over here, I do not know what these different colors are representing. So in order to have that on my pie chart, all I have to do is say labels equal to count dot index, and if I print it now, you can see the green color represents my finance, blue represents HR, and orange represents IT. But again, another issue is I do not know the values of these sectors. So in order to get my values printed in my pie chart, all I have to do is say auto PCT and pass 1.1%, 1.1 F. So you can see I have 40% HR, 30% IT and 30% finance. Okay. So the format I've given over here basically represents that I want one decimal. If I were to pass 1.0, I would get only my integer parts over here. If I were to say 1.2, you can see I got 2 decimal values in each of my sectors. Okay. And another important parameter in pie chart is explode. So the explode feature basically helps us decide if we want to separate any particular section in our pie chart. So let me just show you guys. So I can simply say 0, 0.1 and 0. If I do that, so you can see IT, which is my second sector over here, has been separated from my entire pie chart by 0.1 distance. Okay, I can do that for 2 sectors at a time also. I can say I want this to be separated by 0.2, the last sector finance. So this is what my pie chart looks like now. Okay, now if you feel that your pie chart is not a complete circle, it's not a proper circle, you can quickly go ahead and say axis and pass equal in the parenthesis, and that will make your pie chart in a complete circle. Okay, so this was one way of visualizing a categorical column. The other one is known as count plot. So in order to do a count plot, all you have to do is say plt.bar and pass your count.index and count variable and simply say plt.show, and now you can see your different sectors represented as a bar chart. Okay, you can easily understand that HR has 8 values, basically 8 people working in HR, 6 people working in IT, and again 6 people working in finance. You can also go ahead and change the color of your bars. You can make it, so if I want different colors for different bars, so I can go ahead and say green, black, red. So you can see I have different colors for my different bars. Okay. So this was all about univariate analysis. That is when we had to deal with only one column. Either it was just a numerical column or just a categorical column. But what if we had two columns at a time? That brings us to our next type of analysis, that is bivariate analysis. And over here, we basically try to analyze the relationship between two features or two columns. So first we're going to look at two numerical columns. Okay. So right now, if I check my data set, I have one numerical column and one categorical column, right? So in order to perform numerical analysis, I should have another numerical column. So let me just go ahead and create a new column. I'm going to call it age. And okay, so this is my new column called age. And if I go ahead and check my data frame now, so you can see I have three columns. Two are numerical columns and one is a categorical column. Alright. So now if I want to visualize salary and age column together, the first plot that I have is known as a scatter plot. So a scatter plot is basically going to help us analyze the direct relationship whether salary increases with age or not. Okay, so if we want to check that, all we have to do is say plt.scatter and pass my age column, my salary column, and I'm going to give the color orange. And I'm simply going to say plt.show. So as you can see over here, my age and salary are increasing together. Okay. So this is also known as a positive correlation. Alright. So when my age is around 20 to 25, my salary is somewhere around 25,000 to 30,000. But as my age increases, so when I reach the age of 40, my salary is somewhere around 55,000. Okay, so this is how you can analyze the relationship between two numerical columns. And the next way of visualizing two columns is again by using a line plot. So as we saw in our initial example, we had two features X and Y. So right now we have two features called age and salary. So I'm going to go ahead and plot my line graph over here. So as you can see, my line graph is not very easy to visualize over here. You can see the lines are very random. So instead of line style as dotted, I'm going to have my simple and plain line style. So as you can see, it's going back and forth a lot. So why is this happening? Because my age column is not sorted over here. So I have random age values and random salary values. So in order to have a better visualization, what I'm going to do is I'm going to sort my age feature. I'm going to create a variable called sort age, and I'm going to simply sort my values of age. Okay, and over here, instead of passing my age directly, I'm going to pass my sorted age. So as you can see over here, now my line chart is giving me a better visualization of the relationship between the age column and the salary column. Okay, so this is how you can plot a line chart between two numerical columns. Then the next visualization graph that we have is a bar chart. So in order to plot a bar chart, all you have to do is say plt.bar, pass your age. I'm going to pass my sorted age features and my salary column, and I'm going to say I want my color to be green for all the bars. And as you can see over here, it is giving you the visual representation in forms of bars. Okay, so at the age of 22, I have my salary in this range. At the age of 25, I have the salary at this range. So I can also go ahead and create bins. So I want only 10 bars to classify my age. So I can also go ahead and align my bars, and I can say I want my bars to be in center. So if I run it, so they were initially like this. Now if I say I want them to be left, so align supports center or edge parameters. Okay, so this is how you visualize two numerical columns, but what if you had a numerical and a categorical column to visualize? So let me go ahead and show you guys bivariate analysis, but with a numerical and a categorical. So I'm going to consider my salary feature and my department feature, and now I want to see the visualization of how my salary is distributed according to my department. Okay, so what I'm going to do is I'm going to create my feature called HR salaries, and here I'm going to fetch all my salaries that have the department of HR. So basically my HR salary variable is going to contain the salaries of only the HR department. So basically these are the people working in the HR department and these are their salaries. Okay. Similarly, I'm going to do that for the other two departments as well. So I'm going to create IT salary, and similarly I'm going to create finance salary. Okay. So once I have my salaries for all the three departments separately, I can go ahead and plot them in a box plot. So I'm going to go ahead and create a box plot. So in order to do that, all I have to do is say plt.boxplot and pass all the three salaries that I have together. And you can see the distribution like this. Okay, so I have one salary that is an outlier, that is 55,000, which is okay. So I need to also go ahead and label them. So I'm going to say label, and I'm also going to show the legend for my plots. So if I plot this, you can see I have three box plots, and over here you can see I have an outlier value for my first box plot, but in this particular figure, I'm unable to understand which box plot is referring to which department. So in order to clarify that, I can go ahead and say I want my labels to be HR, IT, and finance. So if I run it now, you can see my first box plot represents the HR department, and I have an outlier value in the HR department. Okay, so this is how you can analyze a numerical column with a categorical column using box plots. Okay, you can also check their median values. So the median HR salary is in the range of 25,000 to 30,000, whereas IT median salary is 35,000, and finance has the highest median salary, that is 40,000. So this is how it gets much easier to visualize data using plots in Matplotlib, right? If you were to find out such insights just looking at the data, it would take you much longer, right? But using graphs like this, I can easily figure out which department has uh, a higher median salary, or the maximum salary, or the outlier lies in which department, right? So boxplot was one way. Another way where you can visualize your numerical and categorical column together is pie chart. So in order to plot my pie chart, what I'm going to do is I'm going to sort, or I'm going to group my salary by department, and I'm going to say df dot group by department, and I want my salary to be grouped, and I'm going to use the sum instead of mean. So this is what it looks like. So I have a total of this number for my finance department. So basically all the people in finance together are earning this much salary, whereas all the people in HR are earning this amount, and in IT they're earning this amount. Okay, so now I can go ahead and plot it in a pie chart. I can say plt.pie, and I can give my salary by department variable, and I can call my labels as the index, and I'm going to label them using auto PCT. And once I print my pie chart, so in my pie chart I can easily see the distribution of salary in percentage for the three different departments. Okay, so this is another way of visualizing. So in my box plot, I could easily figure out the minimum salary, the maximum salary, and the median salaries for all the departments. And over here, I can see the distribution or the percentage for each department, that is the total amount being earned by each department. Okay, so another way when you can visualize your numerical and categorical column is by using a bar plot. So I want to show the mean salaries of all the departments in my bars. So what I'm going to do is I'm going to say HR mean, and I'm simply going to say sum of HR salary and I'm going to divide it by the length of HR. And similarly, I'm going to do it for IT and finance as well. So once I run it, I can simply go ahead and plot my bar chart over here. I'm going to say plt.bar, and I'm going to pass my HR, IT, and finance as labels. And I'm going to pass these as variables as well, and I'm going to say I want my bars to be of color green, black, and red. And once I print my chart, this is what it's going to look like. Okay, so in my bar chart over here, I can easily see the mean or the average salary for the three departments in a very clean and neat manner, right? So my HR mean salary is somewhere around 35,000, whereas IT is a little more, and finance is almost crossing 40,000. Let me just use my grids over here. So you can see now you get a better visualization of the mean or the average salary for the three departments. Okay, So this is going to further help you in analysis where you are building large predictive models. Right now, I just have 3 columns and the values are really small, so I could even look at the data. But when you have a larger number of columns and larger values, visualizing your data becomes a much more easier, or you can say efficient way to understand what the data is trying to tell you, right? So with this, we finish our bivariate analysis. Next comes our multivariate analysis. So basically, this is where we're trying to understand how the 3 columns affect each other and how they change with each other, right? So first, we're going to look at three numerical columns. That is numerical, numerical, numerical. So I'm just going to write 3 numerical columns. So in order to have 3 numerical columns, right now I just have 2 in my data set. Let me just check. Yeah, so I have 2 numerical columns, that is salary and age. I need to add another numerical column in my data frame. So let me just say DF and let me add experience. Okay, so you can see I have added another numerical column, that is experience. So basically, this column is telling us how many years of experience the person has. So over here, there's 1 year of experience. Here, over here, the person has 2 years of experience, and so on. Okay. Also, another thing that I missed over here is a few parameters in pie chart. So over here, there's something known as shadow. So if you want to give these effects to your pie chart, you can simply say shadow equal to true, and over here you can see a shadow like structure has been created below your pie chart. Okay, so it kind of gives your image a 3D effect, right? And you can also go ahead and say explode and pass a list of the distance that you want your each sectors to be away from the radius. So I'm going to say 0.1, 0 and 0.1. So basically this makes your pie chart look a little more interactive and different from the normal images that are out there. So you can go ahead and customize it. Okay. Alright, so moving on with our multivariate analysis. So I have 3 numerical columns, as you can see over here. So now in order to analyze these 3 columns together, I'm going to use something known as a bubble plot. Okay. So a bubble plot is nothing but a scatter plot where your third numerical column, so in this case we're going to use experience as our third numerical column, and this experience column is just going to define the bubble size. Okay, so with that you get an idea of how much experience the person has. So basically, the larger your bubble, the more the experience the person has. Okay, so let me go ahead and quickly create this plot for you guys. So I'm going to say plt.scatter. So basically I've passed my age column, my salary column and my experience column as the size of my bubble. And I'm saying I want orange bubbles. And if I print this, okay, so as you can see, the size of my bubble by default is very small. So basically the smallest bubble is representing 1 year of experience and the largest bubble is probably representing 5 years of experience. But in order to have a better visualization, what I'm going to do is I'm going to multiply this by 20. Okay, so now you can see the bubble size has increased and now it's much more easier to visualize this particular graph than earlier. I can also go ahead and increase the number of multiplication. Okay, and I'm going to give the color blue because that would give a better bubble effect. So this is what my bubble plot is going to look like when I have 3 numerical columns. Okay, so you can go ahead and easily visualize that person of age 27 is earning around 35,000, and again the experience is also good, right? So I'm simply going to give the color as sky blue, and I can also go ahead and customize it as edge color. So I'm going to give my edge color as black so that I have a better understanding of my bubbles. Alright, so see, this is what my bubble plot is going to look like. Again, I can give a title to my plot. I can say plt.title, age versus salary versus experience, and my X label is going to be age, my Y label is going to be salary, and I do not need a grid. So now you can see my plot looks much neater and easier to read, right? So this was when we had 3 numerical columns. But what if we had 2 numerical and one categorical column. So in this case, we are going to again use a scatter plot. So the two numerical columns are going to be our age and salary, and our categorical column is going to be the department column. Now, in order to plot this on a scatter plot, instead of using a bubble plot, we're going to use a scatter plot again. But for the different departments in our department column, we are going to use different colors. Okay, so what I'm going to do is I'm going to say plt dot scatter, and I'm going to pass my age column, my salary column, and I'm going to say I want my colors to be of the different departments, that is DF department, and I'm going to say I want the colors of a rainbow. So I want different colors in a rainbow, okay? Or if I didn't want rainbow, I'm going to show you guys how I can customize the colors in my own way. So I'm going to say X label, and my X is going to be age, then Y label, plt dot X label, and plt dot Y label. My Y label is going to be salary, and I'm going to give a title to my plot, and I'm also going to print my legend. Okay, so I cannot use a rainbow color. Rather, what I'm going to do is I'm going to say df.map, and I'm going to map the different departments. So if I have an HR department, I'm going to map it with, say, color yellow. And similarly, I'm going to map my other two departments as well. So I'm going to say IT, I want to be mapped to color blue. And finally, I have finance, say orange. Print it now. So as you can see over here, I've tried to print my legend, but I am not really getting an output. So I can resolve this by simply saying labels equal to df department. So as you can see over here, I have tried to print my legend using plt.legend, but I am not really getting any output for that particular line. So the reason being, I have explicitly defined what colors each of my departments are going to get, and Matplotlib is unable to read that. So I have to explicitly define the labels using label, and I'm going to say HR, IT, and finance. So if I print it now, so as you can see over here, even though we've passed the plt.legend parameter, our legend is not getting printed. So the reason is because we have explicitly defined the colors over here, and even if we try to get the label parameter as df department, so you can see it is not going to work for us. So we cannot use this particular strategy. Rather, we have to follow a different kind of format over here where we explicitly define our color using a variable. So I'm going to say my HR is going to be linked with yellow, IT is going to be with blue, finance is going to be with orange. Okay, now I'm going to iterate through each of my color and my department. So I'm going to say for DPT and color in color.items, and basically I'm going to classify each of the departments separately, and then I'm going to print my scatter plot of age and salary. I'm going to say my color is going to be the specific color for each department, and I'm going to label my department. And if I run this and I go ahead and print my legend, so now you can see I've got my legend successfully, because now Matplotlib knows which department is representing which color. Alright, so that is why it is able to generate a legend successfully. Earlier in this case, Matplotlib had no idea about it. So this is how you can create a legend when you're plotting two numerical and one categorical column in a scatter plot. Alright, so that was all about our PyPlot API plotting for a single numerical column, a single categorical column, then two numerical columns versus a numerical and a categorical column. Then we went ahead and saw multivariate plotting, and we did all that using the PyPlot API. That is, we directly went ahead and used terms like plt.bar, plt.boxplot, and so on. Now we're going to dive into object-oriented API. That is, we're going to create objects before we start plotting. Okay, so let me just comment it over here. So object-oriented API basically allows subplots or multiple axes or multiple plots in a particular figure. Okay, so till now we saw one particular plot in one figure, but now what we can do is we can have multiple plots and subplots in a single figure. Okay, so let's quickly see how. So first I'm going to create two objects called figure and axis, and I'm going to say plt.subplots, and I'm going to pass 1 comma 3, and I'm going to say my figure size is going to be 10 comma 5. Okay, so this is basically the x and y ratio. So in terms of x, I'm going to have the figure horizontally expanded and vertically just 5. Okay, so basically what I'm telling my subplot parameter is that I want one figure, and in that one figure I want 3 subplots. Okay, so now let's go ahead and create our first plot. So I want my first plot to be a line plot. Okay, so as you can see over here, this is one complete figure and I have 3 subplots. Right now all these 3 plots are empty. Okay, so I'm going to go ahead and create my line plot first. So in order to do that, I'm going to use my sort age variable. Let me see if I still have it. Yes. Okay, so I'm going to use my sort age variable. So I'm going to say at my axis 0, that is my 0th x axis, I want to plot a line plot, and it is going to be sort age, pass my age and salary, and I want my color to be red, my marker to be a star, and my line width to be 2. Okay, I can also go ahead and define my marker size. So I'm going to say marker size equal to 2. So I can go ahead and set the grid. I can also set my title for this particular plot. I'm going to say it's a line plot, and I can also go ahead and set my x label and my y label for this. So I'm going to say dot set x label, and I'm going to call it age, and y label is going to be my salary, and then I'm just going to run it. Okay, so since I've not called my plot till now, it's not being generated. Now I'm going to go ahead and plot my histogram. Ideally all this should be run in a single cell, so I'm just going to paste it in my cell over here, and then I'm going to plot my histogram. And over here my axis is going to be 1, so that Matplotlib understands that this was my first plot, and I'm going to use axis 1 over here throughout histogram, so that Matplotlib understands that this is the second figure, while the earlier where I use 0 for axis is going to be my first figure. Alright, so basically I'm referencing to my first figure and my second figure over here. So I've created a histogram for my salary, and I'm going to give the color sky blue. And I'm going to set my title for histogram, and I'm going to set my label salary, and y label is going to be frequency. Then my third plot is going to be a box plot, where I'm going to say axis 2, that means my third figure, and I'm going to plot my salary over here. I'm going to set my title as box plot, and I'm setting my x label as salary again. And if I run plt.show, that is I print all my plots, this is what it's going to look like. So as you can see over here, my plot is sort of coinciding with my second plot. So I can go ahead and increase my x-axis direction. So I can say 15 comma 5. Now you can see it's fitting perfectly. Okay, so you can go ahead and adjust the dimensions for your plots, that is your figure size. Okay, so this is how you plot multiple plots together, okay, in using object-oriented API. Cool. Now, if I want to save this particular figure in my local environment, maybe I want to use it for some sort of presentation or any sort of document that I'm preparing, and I want to use this figure in that, how do I do that? Okay, so you can either just right click and go to copy image, but that's not the right way. So Matplotlib offers an inbuilt feature where you can save your image. So all you have to do is say plt.savefig and give a name to your image. So I'm just going to say multiple plots. And now you can use any particular extension. So I'm going to use PNG. You can use the JPG format, or you can use the PDF format. Okay, any format that you want to download your image in, you can just use that particular extension in the end using the dot. So whichever image I need to save, I just need to run this particular line before the plt.show. And if I run this, so let me see if my image has been saved. So as you can see over here, multiple plots.png has been saved in my drives. So since I'm using Google Colab, it is unable to access my local environment, and hence my image is saved only in my drive, that is my disk space over here. If you're using VS Code or any other notebook like Jupyter Notebook, you can specify the path that you want your image to be saved in. Okay, so you can directly go and say, I want it to be stored in my C drive. Okay, so you can use a path like this so that your image is stored in that particular folder. And I can also go ahead and download it from here. So this is how you save an image. I can also save it in, okay, let me just go ahead and, so if I click on this is what my image is going to look like. Okay. Now, before we wrap up with our 3D plots, I want to show you guys another interesting scenario where we have a data somewhat like this. Okay, so basically I have multiple numerical columns. Now, if I want to visualize all these particular metrics over here, like the sales and profit and expenses all together in one chart with reference to the year column, this is how I can do it. So first I'm going to convert it into a data frame. I'm going to call it df2. This also ideally should be data2 because I already have data variable initially. Okay. So in order to do multiple plots, all I have to do is say plt.plot and pass my year as my x variable. So this is going to be fixed throughout. All my x variables are going to have the column year because I want all these particular metrics to be represented with reference to year, but in a single plot. Okay, so this is how I'm going to do it. So I do year and let me plot sales, and I'm going to label it as sales. So similarly, I'm going to do it for profit and expenses column as well. Okay, and I'm going to label it as profit and expenses. So if I give my plot a title, financial analysis, and I'm going to label my X label as year and Y label as the amount. So now my Y label, that is the amount, is going to vary according to sales, profit and expenses. Okay. So if I run this, okay, so as you can see over here, I have my profit, my expenses and my sales. Now how do I know which line is representing what? I can see it through the legend over here. And my x-axis is representing the year and my y-axis is representing the amount. Okay, so basically we had lesser profit and our expenses were greater than our profit throughout the years. So basically the company is in financial loss. So that is something that we can easily predict through this particular graph. Although our sales were pretty high, we are not generating the required profit, right? So this is how you can analyze financial data in just a few lines of code. All right. So now coming to the last topic for this particular video, that is a 3D plot. So let's plot a 3D plot for this particular data frame that we have. Okay, so in order to do a 3D plot, all you have to do is create a variable. So I'm going to call it AX and I'm going to say plt.figure and I'm going to say projection equal to 3D. Okay, and now I'm going to create my scatter plot and I'm going to pass my variables. So I'm going to pass my age, salary and experience column and I'm simply going to say df plt.show. Okay, sorry, it's not going to be plt.figure, it's going to be plt.axis and my d is going to be small. Okay, so as you can see over here, I've got a 3D plot. So in order to clarify what each of these axes is representing, I'm going to label these axes. And in a 3D plot, I'm going to use set X label, set Y label and set Z label. Alright, so once I run it, so as you can see over here, this particular axis represents age, this represents salary, and this one over here is supposed to represent experience, but I'm not really getting the label over here. So this code is going to perform better if it was run on a visual code or Jupyter Notebook. Okay, Google Colab does not really support a lot of 3D animations. So if you were to run this particular code in VS Code, you would be able to rotate your graph on different axes and be able to visualize the data better. So if you want to achieve the same functionality in Google Colab, all you have to do is import plotly.express as px, and if you run it, so it's run successfully. And then you can simply go ahead and create your figure, which is going to be your scatter plot 3D. So it directly comes with a 3D scatter plot, and you can pass your data frame, and your variables are going to be age, salary, and experience. So what I've done over here is I've created a figure variable and I've used px.scatter3d. So it's directly going to plot a 3D scatter plot, and I've passed my data frame, my age, salary, and experience variables, and I've titled it as 3D scatter plot. Okay. Now all I have to do is say fig.show, and if I run it, so as you can see over here, now I am able to rotate my graph. I can visualize the data on a 3D level. Okay, so this is how you can do it using Plotly library. Okay. Matplotlib also offers this particular option, this particular functionality, but just not in Google Colab. Okay, you can do it on Visual Code or Jupyter Notebook. I hope you guys were able to understand Matplotlib, the functionalities, and most importantly, which plot is supposed to be used for what kind of data set. So we've discussed univariate, bivariate, and multivariate analysis along with PyPlot API and object-oriented API. So I hope this video was helpful to you guys. So in the last video, we saw how we can plot different graphs using Matplotlib. But there are some limitations with Matplotlib when it comes to customizing your plots or even grouping data. All of this requires more lines of code as it has to be done manually. This is where Seaborn comes in. It is powerful and easy to use as it is built on top of Matplotlib. So in this video, we will be looking at the different kinds of plots like regression, relational, multi-grid plots, and so on in a very simple and easy manner. So without wasting any time, let's get started. Alright, so the very first thing that we have also seen with our previous libraries, we have to install them using the pip command. So all you have to do is say pip install Seaborn, and you have to run this particular command in any of your terminals, your command prompt, right? So once you have installed the library, all you have to do is import it. So you can say import Seaborn, and I'm going to use an alias called SNS because that's the common practice again. And along with Seaborn, I'm also going to import pandas as ed and numpy. So these are all the libraries that I will be using. Now, one thing that I absolutely love about Seaborn is that it's got a number of inbuilt data sets. What I mean by that, let me quickly show you guys. So all you have to do is say sns dot get underscore dataset underscore names, and if you just run it, you get a list of all the data sets that come within Seaborn, right? So you have anagrams. You can go ahead and load these data sets and just take a look at what's stored inside these. But I'm going to go ahead with the penguins data sets because I'm obsessed with penguins. So all you have to do in order to load the data set is give a variable. So I'm going to use the variable name penguins, and I'm simply going to say sns dot load underscore dataset, and I'm going to pass my dataset name, that is penguins. So you can just copy paste from here in order to avoid any errors. I'm also going to see the top 5 entries of my dataset, what it's going to look like. So these are my columns: species, island, bill length, bill depth, flipper length, body mass, and the sex or the gender of the penguins, right? So let me just see what all different species exist inside my dataset. So the basic EDA that I'm going to perform, I have already covered in my pandas tutorial. So if you guys have not watched it and you guys are finding it a little confusing what I'm going to do over here, you guys can quickly go ahead and watch the pandas tutorial. I have provided the link in the description. So inside the penguins data set, I'm going to specify my column, that is my species, and I'm going to say value underscore counts, and I'm going to run it. So as you can see, I have 3 different species and these are their counts. Right, so I have 152 Adelie species, 124 Gentoo species, and 68 Chinstrap species. Similarly, I'm going to see the different islands that these penguins are distributed on. So simply I'm going to pass the island column over here. So if I run it, there. So again, I have 3 different islands, that is Bisco, Dream, and Togersen, and these are their counts, right? So I'm getting a little bit of an idea about my data set. So I have three different species and three different islands that these species reside on. So, guys, one more important thing, it's very important to know about the features in your data set before you actually start working with your data set, because until and unless you know what these features are representing, you will not be able to do the right analysis, right? So, let me quickly show you guys. So, I have an image over here which is perfectly representing the bill length, the bill depth, the flipper length, the flipper depth, and the foot of a penguin. So basically, these are the different measurements done on a penguin. So now that you guys have a basic idea, let's go ahead with our very first plot, that is a scatter plot. So what I'm going to do here is just say SNS dot scatter plot, and I'm going to pass my first parameter, that is the data. My data is stored in the variable penguins, and my x variable is going to be my flipper length. So flipper underscore length underscore mm. So it is in millimeters. Then I have my y variable. So I'm going to represent the body mass given in grams, and I'm simply going to plot it. Okay. So there you have your scatter plot. So basically, what this graph is telling us is that as the flipper length increases, so does the body mass. Okay. So in general, whenever a penguin has a higher body mass, say above 6,000, the flipper length is going to be around 220. Okay, so this is what the data is trying to represent over here. Now, Seaborn lets you pass a third feature as well. So you have your x variable, you have your y variable. Now you can pass in other features. So say I want to distinguish, or I want to see which of these penguins belong to which island, right? So simply what I'm going to do is I'm going to say hue, and I'm going to pass my island feature, and this is the graph that I get. Okay. So I have the three different colors representing the three different islands. Now you can easily see that the islands represented by the green and the blue dot, that is Dream and Togerson, have lower body mass and lower flipper length of penguins, right? Whereas this particular island, Disco Island, has comparatively higher body mass and higher flipper length or greater flipper length. Now, instead of island, I can also pass the sex feature. This is what my graph is going to look like, right? So male and female. So again, you can see the male penguins have a higher body mass and a higher flipper length as compared to the female penguins. All right. Alright, so basically Seaborn allows us a few default styling themes like white grid, dark grid, and text. There are two methods basically. So one is set style, okay, and the other one is set context. So first, let's go ahead and look at set style. So over here, you can basically set the different backgrounds. So if I say sns.setStyle and pass the parameter text, this is the kind of graph that I'll be returned. If I say white grid, you can see I am going to be returned a graph that will have grids and the background will be white. Similarly, I can do just dark, and over here the background is turned dark, and instead of dark I can say dark grid, and now I have a dark background with grids. Okay, so basically these are the different background styles that you can set with the help of sns.setStyle, and all you have to do is simply pass the parameter whatever background you want. And then you can just go ahead and plot your graph. Another thing that you can do in Seaborn is sns.dspine. And by default, it is going to help you remove the top and right spines of your graph. Okay, so let me just set the background to text. And now if you see, the top and the right spines are removed. If I say left equal to true, so you can see my left spine has also been removed. Okay, so I can go ahead and customize my graph in this particular manner. Another thing that I want you guys to know about is set context. So Seaborn has four different types of context. So context basically means that you can override the default parameters. So you can change things like the size of your labels, the lines, and other elements of your plot, but not the overall style. Okay, so the overall style is set by your set style parameter, whereas your context, like the size of your labels, your text, your lines, that is set by set context method. So let us just see the different types of context that Seaborn has. So the first one is paper. So this contains of small elements and it is more ideal for printing in academic papers. Then you have notebook, which is what we are working on, right? So this is supposed to be an ideal context for all the graphs. So this has medium sized labels and text, and it is good for working inside a Jupyter or Google Colab for that matter. Then we have talk, which is for presentations. It is going to have large text and lines. It is going to help in increasing the readability of our plots. Then we have posters. So this has very large elements. That is, all your fonts and styles are going to be extremely large so that they are printed in an efficient manner for large displays or posters. Okay, so now that you guys have understood, let us go ahead and set our context. So let me just do it for this particular plot itself. Okay, sns.set context, and I'm going to do poster for this particular graph. And now, as you can see, all my fonts and my plots, right, all my data points also have increased in size. If I were to say talk, they would decrease a little, right? So you can see they have decreased a little. If I say paper, they're going to be extremely small in size, as you can see over here, right? This is ideal for printing. Let me just remove this particular parameter because I want my left spine to be there, right? And the last one that we have is notebook, which is, I think, our by default context. Yeah, these are the different contexts and these are different styles that we just discussed. Then there's something known as palette. Okay, this is very important when it comes to styling. So you have different sets in your palette. So set 1 is basically going to contain your bright and high contrast colors. Again, you can by default assign the different colors, but if you do not want to remember each and every color, you do not want to go that extra mile, you can just by default pass set 1, set 2, set 3 as your palette. And set 1 is going to have your bright and high contrast colors, whereas set 2 is going to have more softer or pastel colors. So it could include shades like baby pink and sky blue. Whereas set 3 is going to be a mix of soft and bold. That is, it is going to have a varied hue. Okay, so these have 9, 8, and 12 respectively distinct colors. So these are the three sets, but your palette or your color palette also has different parameters like deep. So this is going to have a rich and balanced shade of colors, whereas muted is going to be comparatively softer range of colors or softer shade of colors. Bright is going to again be your high contrast bold colors. Then pastel is again your soft colors or your pale colors. Then dark is again a little dull side of colors. Then colorblind is optimized for colorblind accessibility. So Seaborn gives you that option as well. So since you have so many options in your palettes, you can also choose your palette type depending on your graph. So if you have a qualitative graph, that is, it is categorical in nature, the color assigned to each group needs to be distinct. Okay, so say suppose you're just plotting the different fruits in your data set. So you can set your palette type to be set 1, set 2, set 3, or pastel 1, dark 2, colorblind, etc. Okay, so this is going to help you distinguish each category based on the groups. Similarly, for sequential data type, that is a data with ordered progression, that is low to high or high to low, you can use a particular color and the different shades of those colors would be assigned to that particular data. So it is going to help you see the magnitude or intensity like population or revenue. Then you have diverging, that is when you have a midpoint and you have negatives as well as positives plotted in a graph. So you can use palettes like cool, warm, or red, blue, and so on. So it is going to help you see the positive versus negative changes in your graph, like the profit or loss or temperature changes. Okay, so these are the different use cases of a palette. So let us go ahead and try some. So in this particular plot, we would say we're sort of qualitatively distinguishing between our features. So I would pass my palette as set 1. So let me see what it's going to look like. Okay, so it's blue, green, and red. If I say set 2, you can see these are the pastel colors. And if I say set 3, there. Okay, so this is not a good choice for this particular graph because I can barely see the yellow color. Okay, so let me do dark 2 for this particular graph. Okay, D is going to be capital. Okay, so I think I'm going to stick to this because this is helping me distinguish all the data points very nicely. Okay, so we saw how we can plot a scatter plot between two numerical features. That is, we saw flipper length versus body mass. Now let me go ahead and plot a scatter plot where my data is going to be penguins and my X feature is going to be species. My Y variable is going to be body mass in grams. Okay, and let me classify this based on the islands. So if I go ahead and see the graph, okay. Now, another thing that I want to add in this graph is I want to see the sex as well. So I want to also classify my data points based on male versus female. So I'm simply going to say style equal to sex. So style is basically going to define the style of our data points. So the round data points are the male data points and the cross data points are the female data points. Okay, so now my legend looks something like this. But now one problem over here is that my data points are overlapping a lot. Okay, so one thing that I can do is I can go ahead and say alpha equal to 0.5. So what this is going to do is it is going to decrease the opacity of my data points by default, and wherever there is an overlap, it is going to have a higher opacity of my data points. Okay, so since it makes reading the data somewhat clearer, it is not very efficient, right? I still cannot figure out a lot of things in this particular graph over here. So another plot that we have that is similar to scatter plot is known as strip plot. And I'm going to do the same thing over here. I'm going to pass my hue as island. And what I'm going to do is I'm going to say jitter equal to true. Okay, let me not do that for now. If I just run it, so now as you can see, my data points are somewhat more scattered, and this plot is giving me a somewhat better representation of my data spread, right? Now what I can do is I can go ahead and pass dodge equal to true. So what this is doing basically, it's going to separate my data points based on my hue. Okay, so earlier I had all these data points clustered together, but now they're spread away. Okay, they're divided based on the different islands. Okay, and I can also say jitter equal to true, which is again going to help me read my data better. Okay, so basically we pass jitter equal to true so that we can randomly spread our data points a little for better readability. Now, in order to randomly spread our data point, we have another plot that is again similar to scatter plot, that is known as swarm plot. Okay, so if you want to plot a swarm plot, all you have to do is say sns dot swarm plot and pass my data is penguins, and my x variable is species, my y variable is body mass in grams, and hue is island. If I go ahead and print my graph, you can see this is what it's going to look like. So it is basically going to give a swarm shape to my data, and this is going to help me read my data in a more efficient manner. So I can clearly see that in the Adelie species, most of the body mass is concentrated between 3,500 and 4,000, whereas there are a very few chinstrap species that reach the body mass index of 4,000. And lastly, the Gentoo species have comparatively higher body mass compared to both these species, right? And as you can see, the Gentoo species are only found on Biscoe Island, whereas chinstrap species are only found in the Dream Island, and Adelie species are the only species that are found on all three islands, right? So you can also figure that out with the help of this particular plot. Now, in order to make it a little more pretty, what I'm going to do is I'm going to set my context to say talk, and I am going to despine my top and right spines in my chart. So there. Okay, so I have modified my graph a little bit using the Seaborn features, and this is what it looks like finally. So we saw how we can visualize two features together. Now, what if I want to just visualize one feature? So for that, I have something known as histogram. We have already seen this in our previous lecture on Matplotlib. So in order to plot my histogram, all I have to do is say sns.hisplot, pass my data, and I want my x-axis to represent my body mass in grams of all the penguins. So as you can see, so this is getting really difficult to read. What I'm going to do is I'm going to set my context back to notebook. Okay. And okay, so now it's much easier to read. So as you can see over here, around 60 penguins have the body mass of 4,000. All right. And only 10 have around 3,000, whereas even fewer, that is around 5, I think 4 or 5 have the body mass of 6,000. Okay, so very few penguins are, I don't know if it's overweight or healthy. I am not aware of that. So you can see the frequency distribution of the body mass. And now I want this to be divided based on the sex of the different penguins. So as you can see over here, more number of females have a lesser body mass. That is in the range of 3,000 to 3,500, whereas in the range of 5,500 to 6,000, more male penguins have a higher body mass, right? So in order to make it better, I'm going to say multiple equal to stack. So this is going to help me stack the different categories of my hues, right? So basically, this is the distribution of male versus female body mass and the different counts that each of these have. So usually a histogram is combined with other plots like a KD plot or a regression plot, which is nothing but a trend line that helps you see the pattern in a more efficient manner. So let us go ahead and see the regression plot. Okay, so it basically helps us see the relationship between two variables and fits a regression line, which is basically a linear line, okay, through all the data points. So in order to plot a regression plot, all you have to do is say sns.regplot and pass your data, and then pass your x variable and y variable and print it. Okay, so as you can see, this is your trend line over here that is passing through your data point. So if you've studied linear regression, this plot becomes much more easy to understand and easy to read. So again, we've talked about the palettes, we've talked about how to style your plots. You can go ahead and experiment with that. I'm not going to go ahead and style each and every plot because again, that would take a lot of time. And if you don't want your data points to be visible over here, you can simply pass scatter equal to false, and now you would be only left with your regression line. Okay. So I want my data points to be visible, and what I can do is I can simply pass my color and I can say I want it to be green in there. Okay, so you can go ahead and play around with your plots using these parameters. Then the next plot that we have is a line plot. So again, a line plot basically helps you visualize a numerical column in a continuous manner, right? So I can go ahead and say sns.lineplot and pass my x variable and my y variable. And let me not use hue right now. So as you can see, this is what my body mass versus flipper length looks like. So when my body mass is around 3,000, my flipper length is around 180. Okay, and when my body mass is around 4,500, my flipper length is around 215 or 218. Okay, so let me just go ahead and say sns.set style, and I want it to be a white grid. So now you can use the grids to help read your plot better. That is, if you are trying to make any inferences. So as you can see, this particular data point is crossing the body mass of 6,000 and it's touching 230. So the maximum flipper length that a penguin has is 230. Now I want to see whether this particular penguin is a male or a female. So I'm going to pass hue equal to sex, and okay, so it's a male, right? So male penguins have higher body mass, whereas a larger flipper length. Okay. Instead of sex, now I want to see the distribution based on island. I can simply pass island in my hue, and I can say style of my line should be represented by the sex. So now I can have both my sex and islands. So the dotted lines basically represent the female penguins, whereas the orange line represents the Bisco Island. Similarly, the green dotted lines are the female penguins at Dream Island, whereas the blue complete line represents the male penguins at Torgeson Island. So this is how you can plot a line plot between two numerical columns. Now there's something known as a join plot, which is nothing but it lets you combine two different plots. Okay, so you can combine two plots, like you can combine a scatter plot and a histogram. So you can simply say sns dot join plot and pass my data to penguins. Okay, so my x variable is going to be the body mass in grams and my y variable is going to be the flipper length. And if I plot this particular plot, So as you can see, this is my scatter plot, and over here on the edges, I get my histogram. So this histogram is basically representing the density of my data points. So wherever I have a higher density, my bars are going to be higher for that particular area. Okay, so this particular area has a higher density, and it is being represented on both the axes in a similar manner. Now I can go ahead and plot a different kind of set of plots in a join plot. If I increase my number of parameters here, I say my hue is 6 for now. And if I plot it, you can see I have scatter plot versus a density plot. So this plot is nothing but a smoother version of a histogram. So over here we have two colors, and these colors are representing the density of, again, the two data points that we have. Okay, so the orange data points are more dense at this particular area, whereas the blue data points are more dense over this area. Okay, so you can also go ahead and manually describe the kind of plots that you want. So I can go ahead and say KDE plot, and over here I would get a plot like this. So this is basically telling us the concentration of data points at a particular place. Okay, so as it's clearly visible over here, I have more data points over here and a slightly less concentration of data points over here. Similarly, for the male penguins, I can see the concentration of the data points. So instead of dividing my data points based on sex, I can also divide them based on the island. That I can pass my bar over here instead of a KD. Okay, no. So kind can be scatter, histogram, hex, KD, regression, or res ID. So let me go ahead and pass regression. Okay. So scatter plot is supported for this particular hue. Okay, if I do not have a parameter hue, I can go ahead and say I want it to be a regression plot, because then I would have my histograms over here, and now I can have a regression line based on these histograms. Okay, so I hope joint plot is clear. Now the next plot that we have is a bar plot. So again, this is very much similar to a histogram. All you have to do is say SNS dot bar plot and pass your data, your x variable and your y variable, and the category that you want to separate your two data points with. And then I have my different species, the body mass represented by each species, and the male and female distribution of both the species. Right, I can go ahead and pass my palette. I want the colors, say, pink and blue. Okay, so similarly, you can also go ahead and change the different parameters. So instead of blue, let me have sky blue. Okay, much better. So this is somewhat a pastel palette version that I have implemented. Okay, so by default, the bar plot is telling us that this is the mean distribution of these species. So basically, what's happening here is the male Adelie species have an average body mass of 4,000, whereas female Adelie species have an average body mass somewhere around 3,400. Okay, so by default, the parameter of estimator is np.mean. Okay, so if I say np.sum instead, okay, there. Now you can see our scale has been changed. So the overall body mass of all the male species of Adelie is somewhere around 3 lakhs. Okay, and similarly, now our scale has been changed to sum. I can also go ahead and change it to median. So I can check the median body mass of all the species based on their sex, that is male and female. I can go ahead and change it to standard deviation. Okay, so this is the standard deviation. I can also go ahead and see the variance. Okay. So this is the added advantage of Seaborn as compared to Matplotlib. If I were to plot a similar graph in Matplotlib, I would have to do a lot of manual calculations side by side in order to get this particular graph. But in Seaborn, I just have to pass a simple parameter called estimator, and I can change the scale or I can change the distribution to the way I want it. Now, what if I want to just simply count the different species of penguins that I have in my data set? So for that particular goal, I have something known as a count plot, which we also saw in Matplotlib. but there was no direct implementation of a count plot in Matplotlib. We had to manually count our categorical data using value counts. But over here in Seaborn, we have a direct implementation where I can simply say sns.countplot, pass my data equal to penguins, and my x variable is simply going to be species. If I go ahead and plot it, okay, so my data frame is not going to be in quotes. I'm sorry about that. Okay. So as you can see, I have around 150 Delhi species, whereas around 65 or 70 chinstrap and around 125 of Gentoo. Okay. So this is the distribution of the various species. I can go ahead and set my hue as island. Okay. And I'm going to go ahead and set my palette to set to there. Okay, so I have the different species in different islands and their count all in one graph. Okay. Alright, so moving on with the next plot, that is box plot. So again, this plot is used for detecting outliers, that is the extremely low or extremely high values in a particular column or feature. Okay, so this particular plot basically helps us identify the different groups in a feature through their quartiles. So a box plot basically uses three quartiles, which is 25%, 50%, and 75%. So let me show you guys through an image over here. So this is what a box plot looks like. So over here, this is an outlier because this is an extremely low value, and box plot has a minimum and a maximum range of value. So over here, for this particular plot, 10 is the minimum value and 90 is the maximum value. The median value lies somewhere around 55. So we have whiskers, which are basically the lines connecting the minimum and the maximum values along with the lower quartile, which is the 25 percentile, and upper quartile, which is the 75 percentile. Median is basically a 50 percentile. Okay. And what these percentiles basically represents is 25 percentile is basically representing all the data points that are below the 25th percent of this particular plot. Okay, so let's go ahead and plot a box plot using Seaborn. So all we have to do is say sns.boxplot and pass your data, which is penguins, and I'm going to have my species. Basically, I'm going to create a box plot for body mass, and I'm going to group it using island, and I want it for the three different species. Okay, so this is what my box plot is going to look like. So I have the three species on my x-axis, and the y-axis is representing my body mass, and these are the box plots for the three different islands. So instead of island, I can also categorize them based on the sex, that is male and female, and this is what they're going to look like. Okay, so basically the chinstrap species have outliers, that is, so there is one male penguin in the chinstrap species that has an extremely high body mass compared to the other species, whereas there is one female penguin in the chinstrap species which has a really low, that is below 3000 body mass. Okay, so this is something that we can easily figure out, and we can also see the median values for all the species and male and female respectively. So again, this particular species has an extremely high body mass for both male and female compared to the other two species. So we can say the male species of these two particular groups are pretty much the same as well as the female species. Okay, so this is basically what a box plot helps you figure out. You can also go ahead and play around with the palette, the colors, the background, and the other context that we just talked about. So the next plot that we have is known as a violin plot. So while I was learning the different plots, I think violin plot was one that I found most difficult to understand. So let me simplify it for you guys. It's very much similar to a box plot, but the only difference is it uses a KD, that is kernel density estimation. So this is what a violin plot basically looks like. Okay. Whatever features we just discussed for a box plot exists the similar way for a violin plot. It has a lower adjacent value, that means it has a minimum value, a maximum value. Okay, the point where this particular line ends is known as the maximum value. The dot over here represents the median, whereas this particular bar, the top part represents the third quartile, that is the 75 percentile, the first quartile, that is the 25 percentile, and these are basically the whiskers. and the outside points are basically anything that lie beyond this particular graph. Okay, so let us go ahead and quickly plot a violin plot, and let me just do it using the same particular features that we used earlier. So if I go ahead and run it, so this is what a violin plot looks like. So again, it is helping us see the distribution of data, and we can also see the shape of our data, right? So I can see that my data points are mostly concentrated over here through this axis. So I can conclude that the female species of chin strap are mostly have the body mass around 3,500. Okay. Similarly, I can do that for the other species as well, looking at the shape of my plot. Now, another thing that the violin plot offers is the split parameter. So if I say split equal to true, this is what my plot is going to look like. Okay, so basically it has been split for my male and female. So this is what a violin plot looks like, and this is how it's done. So basically, as I told you guys earlier, the width of my violin plot is going to represent the density of the data at different values. So if you see the plot being stretched at a particular point, you need to know that the data points are concentrated at that particular point. The middle line over here is the median value, and the thick bar is the interquartile range. That is, if there is an inner box equal to true. Okay, so if I pass inner equal to box, so what this is trying to tell us is this particular box over here is basically representing our interquartile range, that is IQR. So the interquartile range is nothing but the third quartile minus the first quartile. Okay. So that's it about violin plot. So I hope you guys remember swarm plot that we talked about earlier. So let me show you guys something. So if we do a violin plot for a species and body mass, and on top of that, if I do a swarm plot, and my x is again going to be species, and y is going to be my body mass, and my color is going to be black, and let me have the size of my data points as 3. If I plot this, so as you can see, my swarm plot is going to fit exactly inside my violin plot like this. Okay, so I can clearly see the distribution of my data points with the help of these two particular plots. Also, instead of passing the color black, over here, what I can do is I can pass my hue as eyelids. I'm going to give this a palette pastel, and if I run it now, okay, and over here I'm going to have palette of dark. Okay, so this is what my plot is going to look like. Then the next plot that we have is known as a KDE plot. So this is nothing but a kernel density estimation plot. So a KD is basically a probability density function of continuous data. In simple terms, we can say that it is a smooth version of a histogram. So it basically shows the distribution of data, just like histogram. So instead of bars, we have a line, and if we pass a hue function, we can have different color of lines. So it's basically going to help us see where the data is concentrated with the help of the peaks, and how it spreads with the help of the density of the graph. So in order to plot a KDE plot, all I have to do is say sns.kde plot, pass my data, my x variable, and pass my hue. And I'm going to say fill equal to true because I want my colors to be completely inside these particular lines. If I make this particular parameter as false, there it's just lines. Okay, so this is basically what a KDE plot is. This is basically just representing a histogram in a different manner. Okay, so I'm going to make this true because it looks much better with filled in graphs. Alright, so the next plot that we have is a heat map. So it is a 2D color coded matrix that shows the relationships or patterns between two or more variables. Okay, so it is commonly used to show the correlation between features. Visualizing the confusion matrices, that is something that we will be looking into deeply in machine learning in the later stages. And it also helps us highlight the missing data. So it has a simple function where you can see whichever data points are missing using the is null function. Again, that is something that you will be implementing in the later stages. So a heat map only allows to visualize the relationship between numerical columns. So let me go ahead and check which columns over here are numeric. So bill length, bill depth, flipper length, and body mass. Okay, so I can take these particular columns. So let me just copy it. Let me create a variable called columns, and let me just go ahead and pass these particular columns. So basically I've stored all the numerical columns in a list format in this variable columns. Now what I'm going to do is I'm going to create a heat map using sns.heatmap, and then I'm going to say my data is going to be the penguins. Columns are all these columns, and I'm going to do a correlation on them. Okay, so let me just go ahead and print this for you so you guys know what this CORR function does. So as you can see, it's giving us a correlation. So bill length with bill length has a correlation of 1 because these are the same columns. But the features bill length and bill depth have a negative correlation. That means that as the bill length increases, the bill depth decreases. Okay. But bill length and flipper length have a positive correlation, which means as bill length increases, so does flipper length increase. Okay. Same with body mass. So this is basically what correlation means. It gives us the relationship between two numerical columns, whether one increases with the other or not. Okay. So for now, let me just go ahead and pass this in my heat map and see what it looks like. So as you can see over here, it's giving me a color encoded information about the correlation between these particular columns. So instead of numbers like this, we have colors which represent the different information. So the highest correlation has a peach color. Okay, so this is why all the diagonals have a peach color over here. And black represents very strong negative correlation. So flipper length and bill depth. Okay, so these two particular have a very high negative correlation, and body mass and bill depth also have a negative correlation. Okay, so this is something that you can infer from this particular graph. Now what I can do is I can say a note equal to true. So this is going to label my information on my color encoded box. So over here now it gets very easy for me to read this particular graph. I can also go ahead and change my color to, I can say, blues. So I want all the blues in my graph. So you can see the different shades of blue. The extremely dark shade of blue represents a positively high correlation, whereas a lighter shade of blue represents a negative correlation. Okay, so you can see it's almost white. And as the correlation moves towards the positive side, so does the shade of blue move to the darker side. Okay, so this is what is happening. Now, another thing that I can tweak over here is, say I want my negative correlation to start from 0.2 rather than minus 0.5. So what I'm going to do is I'm going to say vmin, and I'm going to say I want it to be from minus 0.2, and once I run it, you can see my negative correlation is starting from minus 0.2 rather than minus 0.4. Okay, so I have changed my scale completely. And since my scale has been changed, the color over here of my boxes has also been changed. Okay, so this is how a heat map works. You can go ahead and play around with other parameters like line width. I can say I want it to be 2. Right now I think it's 0. Okay, so as you can see, I have a line between all my boxes over here, and right now it's white. I can go ahead and change my line color to black. So there. Alright, so moving on to the next plot, that is rug plot. So this is a very simple plot that adds small ticks or small lines, vertical lines along the axis that you define. And these ticks, like rugs, basically represent the different data points of your feature or your column. Okay. So these rug plots are generally used along with histograms or KD plots to give a little extra detail to your plot. So in order to plot a simple rug plot, all you have to do is say sns.rugplot and pass your data, which is penguins, pass your x and y variable, and I'm going to set my palette to set2. Okay, and once I run it, so you can see these are my lines over here representing the different species. I have passed my x variable as body mass and my hue is species. If I say I want this to be my y variable, my rug plot is going to be over here. Okay, I can also go ahead and change the height of all these vertical lines or rugs. I'm going to give it, say, 2. It's going to be pretty big. Okay, I was supposed to do it 0.2. Okay, so this is about rug plot. So the next plot that we have is a pair plot. Okay, so this is basically a grid of plots that shows the relationship between all the numerical variables in a data frame. Okay, so it basically does multiple plots together and helps you visualize all of these numerical variables together. So it's going to use a single plot to visualize the pairwise relationships and distributions in a data set. So in order to do a pair plot, all you have to do is say sns dot pair plot, and we already have a list or variable specifying all our numerical columns. So I'm just going to go and use that. So my data is going to be penguins and all the columns that we specified. And if I go ahead and plot it, okay, if I do not pass this particular thing over here, so unlike a heat map, your pair plot is not going to raise an error if you pass your entire data frame at once, which is obviously going to contain categorical columns as well. So what pair plot does is it automatically filters out all the categorical columns and works only with the numerical columns. Okay, so I have not passed the numerical columns explicitly. Rather, pair plot has done it by default, right? So I can go ahead and play around a little with my features. I can say I want my hue to be sex, and I'm going to give my palette as set 2. I don't know, I'm obsessed with set 2. And I'm going to say I want my diagonal lines to be KD. That is, I want it to be the KD plot for the diagonal direction. And as you can see, I have the diagonal line covered with KD and I have scatter plot for all the other features. Okay, so this is a pretty big plot having multiple pairwise relationships. Okay, so you can go ahead and understand them all one by one. I'm not going to do that right now because that's going to take up a lot of time. Rather, what I'm going to do is I'm going to show you the different parameters that exist in pair plot and how you can use them. Okay, so basically what a pair plot is doing over here is it is showing you a lower triangle and an upper triangle. Okay, so this is a pair plot. Over here we have a diagonal line which we have specified to be as KDE. Okay, and then what we're left with is a lower triangle and an upper triangle. So we have scatter plots for our lower triangle as well as upper triangle. For our diagonal, we can either specify our distribution to be a KDE plot or it can be a histogram. So I've just written hist over here. So this is basically what's happening. So if I go ahead and try to have my lower triangle, so I can go ahead and change this to histogram, which was there previously. There. So you have your histogram and you have your scatter plots. Okay, so this is what a pair plot looks like. Now the last plot for this particular video is a pair grid. Now this is an interesting one because mostly this is not covered in many places. So a pair grid is basically a subplot grid for plotting pairwise relationships in a data set. Okay, so it's very similar to a pair plot, but we're going to see how it acts differently or how it behaves differently. So I'm going to go ahead and create a variable called graph, and then I'm going to say sns dot pair grid and pass my data as penguins, and I'm going to classify my hue with sex, and I'm going to give my palette set 2, and then I'm going to define that in my upper triangle I want a scatter plot, in my lower triangle I want a KDE plot, and on the diagonal I want a histogram. Okay, so now what I'm doing over here is I am defining each and every parameter on my own. I'm defining my lower triangle. Okay, this is my upper triangle. This is my lower triangle. And this is my diagonal. If I run it, so as I defined, I wanted a scatter plot in my upper triangle. So as you can see over here, these are my scatter plots in my upper triangle. I wanted KD plots in my lower triangle. So we have KD in our lower triangle, and I wanted a histogram on my diagonal. So this is how you can define the various parameters. And you can also go ahead and say graph dot add legend, So this is going to give me a legend. So now as you can see over here, I have my legend, which is specifying the different colors, which one represents male and female. I hope you guys understood Seaborn, and I hope you guys found it much easier to work with comparatively to Matplotlib. Alright, so far we've covered the basics of Python. We've also explored a little bit of NumPy, and we have seen how we can work with datasets using Pandas. Now the next step is EDA, or Exploratory Data Analysis. This is also one of the most important steps in data analytics. This is where you truly begin to understand the data. In the next few sections, you will be learning how to create reports and dashboards, but in order to do that, you need to have a clean data. So in this section, we will be learning how to deal with missing values, duplicate values, and more. So without wasting any time, let's quickly dive in. I want you guys to open your Jupyter Notebook or VS Code or any sort of compiler you are comfortable with. It could be Anaconda, right? So in order to get started, I'm going to quickly go ahead and import all the libraries. So first one is going to be Pandas as PD. Then I'm going to import my NumPy. So I've imported Pandas and NumPy, and for visualization, I've imported Matplotlib and Seaborn. So I want to quickly remind you guys, I have created detailed courses on all of these 4 libraries. So if you guys have any sort of doubt or you guys want to clear your concepts for any of these libraries, I would recommend you to quickly go ahead and watch those videos. I have provided the link in the description. Alright, so if once I have imported my library, the next step is to import my dataset. So I'm going to go ahead and upload the dataset on my drive first. Okay, so this is my dataset over here. People, and in the bracket I have ints. It's a little complicated name, so I'm just going to copy the path over here. And I'm going to store my dataset in the variable df, and I'm going to say pd.read underscore CSV, and I've simply passed the path in quotes, right? So let's see if I run it. Now I'm going to go ahead and see the first 5 entries of my dataset. So this is what it looks like. Now I want to give you guys a quick detail about the dataset. So this dataset is basically for HR analytics. So this dataset is basically of the employees of the company for the past years, and this is basically a sort of feedback form. Okay, so you have your satisfactory level, last evaluation, number of projects, and so on. So let us quickly go ahead and understand what each of these columns represent. Satisfactory level is how satisfied the employee is with the company or was. Okay, so we have the scale of 0.38, 0.8. So you can assume that this is in percentage. So the employee was satisfied 38%, 80%, 11%, 37%, and so on. Okay. When the last evaluation was conducted, the employee was satisfied by 53%, 86%, and so on. So either there is a drop in the satisfactory level or there is a rise in the satisfactory level. Okay. Then we have number of projects. So how many projects the employee was assigned? What was the average monthly hours of the employee? How many years the employee had spent in the company? If there were any work accidents basically represent the conflicts. If the employee was ever involved in any sort of conflict in the company, whether the employee is currently working or not. So if for a particular employee there is 1 in the left column, that means the employee is no longer working in the company. Then we have promotion in last 5 years. So 0 represents that the employee did not get any promotion in last 5 years. Then we have the department column. So we have sales and there will be other departments as well. We're going to quickly go ahead and check which all departments are present in the particular data set. Then we have salary, low, medium, and there will probably be high as well. Okay, so let me go and get more information about my data set. I know very little about my data set till now. Okay, so satisfactory level is a float data type column. We have department and salary as our objects, and we do not have any null value as far as I can see. Let me just check the shape of the data set to be sure. Yeah, so we have 14999 entries, and as you can see, all of these columns are non-null, right? So we do not have any sort of missing values in the data set. Okay. The next thing that I can do is I can check how many departments and what all are the salary criteria in our data set. So I'm going to say DF and I'm going to pass department. So we have all these departments: sales, technical support, IT, product management, marketing, and so on. You can see the distribution as well. So there were 4140 people working in sales department, 2720 in technical, and so on. Okay. So you have your department and you have your count. Similarly, let me check for the salary, how many types of salaries are present. So we have low, medium, and high. So as you can see, there are very few employees with a higher salary, right? As we can already see over here, none of our columns have any sort of null value, but just to be sure, what I'm going to do is I'm going to simply say df dot is NA, and then I'm going to pass sum. And as you can see, I have zero null values in any of the columns. Okay, so I do not have to deal with any sort of missing values. Now I'm going to go ahead and check for duplicated values. So I'm going to say df dot duplicated, and then I'm going to calculate the sum of all the duplicates. And as you can see, I have 3008 duplicated values. Now, duplicated values are of no use to me, so I'm going to directly go ahead and say df dot drop duplicates, and I'm going to say in place equal to true because I want to get rid of all these duplicate values in my original data set. So I'm going to go and run it. Now if I check for the duplicate values, let me just copy this line over here. Now you can see I have 0 duplicate values in my data set. Now let me go ahead and check the information of my data set once again. And now you can see the number of entries for all my columns has been decreased. Okay, so earlier it was around 14999, and now I'm just left with 11991. Right, so there's a huge decrement, that is around 3000 rows or 3000 entries have been removed from my data set. Now the next thing that I'm going to do is I'm going to check the statistical summary of my data set by using a very simple syntax, that is df.describe and empty parenthesis. And now over here, I get the entire statistical summary of my data set. Right? I can see all the counts, the mean value of my entire columns, my standard deviation, the minimum value, the maximum value, and the percentiles over here. Okay. And one important thing is whenever I'm getting a statistical summary, I'm only going to get it for all the numerical columns, right? So as you can see over here, I only have my float and integer columns, whereas the object data type columns, department and salary are not included over here. All right. So now in order to get started with EDA, as I mentioned earlier, we have to ask the right questions, right? So the first question that I'm going to ask is, do the number of projects affect the employees leaving the company? Okay. So this can tell a lot about the work distribution process in a company if we get the right insights, right? So let us quickly go ahead and answer this question. So I'm going to use Seaborn library and I'm going to use the count plot in order to plot the graph, and my X variable is going to represent my projects, and I'm going to separate them with the left column. So my hue is going to separate. Alright, so in order to answer this question, what I'm going to do is I'm going to go ahead and plot a count plot using the Seaborn library. So if you guys remember the Seaborn tutorial, this is how we plot a count plot, right? And what the count plot is going to tell us, it is going to tell us the number of distribution of projects across the employees, right? And I'm simply going to say number of projects, and let me see what the graph looks like. Alright, so in order to answer this question, what I'm going to do is I'm going to plot a count plot. And if you guys remember, count plot is going to help us see the distribution of the projects across the employees, right? So my data is going to be df, and my x variable is simply going to be number of projects. So if I go ahead and run it, so as you can see over here, 2 projects were distributed among 1500 employees. So around 1500 employees got 2 projects, whereas around 3,500 employees got 3 projects. A little more than that got 4 projects, and around 2,000 got 5 projects, and around 1,000 got 6 projects, and very less number of employees got 7 projects, right? So this is the distribution of number of projects across the employees. Now I want to figure out if the number of projects had any sort of effect on the employees leaving the company. So in order to do that, I'm going to add another parameter to this particular graph, which is hue. Now I'm going to say I want it to be differentiated based on whether the employee left the company or not. So I'm simply going to pass my column left. And if I run it now as you can see over here, I have a legend with me, which is telling me that the blue bar is representing that the employee did not leave the company, whereas the orange bar is telling me that the employee left the company. Okay, so as you can see over here, most of the employees with 2 projects left the company. Very less number of employees with 3 projects left the company. Same with 4 and 5. But if you see for 6 projects, a lot of employees left the company. Same for 7. I think 7, all the employees left the company who were assigned 7 projects. But as you can see, for the employees who got 7 projects, all of them left the company. So what we can conclude from this particular graph is that none of the employees who got 7 projects stayed back in the company. Same with employees who got very less projects, that is less than 3, also had a higher tendency to leave the company. Okay. So these are the two basic conclusions that we could come up with after looking at this graph, right? So what can be the solution for this particular problem that we just witnessed? One solution could be that the projects should be divided between, say, 3 and 5, right? So basically, no employee should get projects that are less than 3 or greater than 5. So basically, they should have a good work life balance and a good workload distribution in order to prevent them from leaving the company. Okay, so this is one basic conclusion that we could come up with looking at just this one simple graph. Now, in order to cross check our conclusion, what I'm going to do is I am going to filter out all the employees who have or who were given 3 number of projects. Okay, so if you go ahead and see the satisfactory level of these employees, it was in a pretty good range, right? 57%, 71%. Okay, there's one employee that had 12%. But if you see the majority of the numbers on your screen, they were above 50%, right? So that was our question 1. Now, the next question that I want you guys to understand and try answering is, does the time spent in the company, or we're going to consider the experience level over here, okay, does it affect the employees leaving the company? Okay. So before I start answering this question, I want you guys to take 2 minutes and try it yourself, and just compare your answer later on. Okay. So in order to answer this particular question, what I'm going to do is I'm going to plot a COM plot again. And this time, the COM plot is going to be between my X variable is going to be time spent dot company, and my hue is again going to be left. So as you can see over here, again, I have a legend telling me that the blue bars are the employees who did not leave the company and the yellow bars are the employees who left the company. So as you can see in this particular graph, employees who spent 2 years in the company, barely any of them left, right? Again, for 3 years, very few of them left the company. For employees with 4 years in the company, the ratio slightly increased over here. For employees with 5 years, the ratio is almost equal, as you can see. So almost half of the people left after getting 5 years of experience in the company. Whereas employees with 6 years, again, very few of them left. And then you have employees with greater than 6 years of experience in the company where none of them left. So what are the conclusions from this particular graph? So can we say that employees with 3, 4, and 5 years of experience tend to leave the company more often? Okay. Whereas employees with experience greater than 6 do not leave the company. Okay. So what can be done in order to prevent these employees with 3, 4, and 5 years of experience from leaving the company? How can you as an HR prevent that from happening? So one solution could be giving more employee benefits. It could be a salary hike. It could be more vacations, more sick leaves, right? So basic employee benefits like that could help retain the employees more. All right. So moving on with the next question. Does the department of the employees affect them leaving the company? So basically, we're going to check the correlation between the departments and the left column. So we're going to see if there is any sort of correlation between those two columns. Okay. So again, what I'm going to do is I'm going to go ahead and plot a COM plot. And this time, my X variable is going to be department, and my hue or my separation parameter is going to be the left column. And if I go ahead and print it, as you can see over here, sales, accounting, HR, technical support, all the departments are on my x-axis and the counts are on the y-axis. Okay, what if I say I want my y-axis to be the departments? There. So this looks better. I can read all the departments in a much more better way over here, right? Okay, so instead of passing y equal to department, what I could have done was I could have said plt dot ticks and I could have rotated my ticks at a 90-degree angle. And then all I had to do was say plt.show in order to avoid any warnings. Okay. Sorry, it's going to be xticks. Okay, so whenever you have large labels on your x-axis and they are merging with the other labels, you can either use this particular method or you can simply plot them on the y-axis. Basically, interchange your axis so that they automatically come in neater format. Okay, so as you can see over here, we have the different departments and we have the legend again telling us that the blue bars are the employees who did not leave and the orange bars are the employees who left. Okay, so as you can see in this particular graph, we have the sales department, technical and support. Okay, so you can see the orange bars going really high up in these three particular departments, right? This is where most of the employees are leaving. Okay, whereas the other departments like accounting, HR, IT, product management, marketing, management, and some random departments, there are very few employees leaving the company. Okay, so that could be a basic conclusion. I am not going to write this one down because this is very basic. It's pretty clear from the graph itself that sales, technical, and support have maximum employees leaving the company. So another important thing while we are plotting these graphs is that we are not able to see the exact values or the exact numbers on these graphs or on these bars, right? So what we can do in order to get the exact values on our graphs, so we're going to follow the API method that we had discussed in our Matplotlib video. So I'm going to assign a variable AX and I'm going to store my count plot in this particular variable. Now what I'm going to do is I'm going to say plt.xticks and I'm going to have them rotated by 90 degrees, okay, as I have already done earlier. This is nothing new. Now what I'm going to do is for x in ax dot containers. Now what I mean by ax dot containers, so basically our ax variable is storing the entire plot. Okay, and containers are basically these individual graphs or individual bars that you can see in the graph. Now basically I'm telling my code that I want to loop through all these bars one by one and simply ax dot bar underscore label. That is, I want to label them. Okay. And I'm going to have the count value of those individual container values. And then I'm going to say plt dot show. If I run it, there's a spelling error, but my graph was still working fine. So as you can see in my graph, now I have the exact number of values of the bars, right? But there is a mistake or there is an error in my graph right now. I want you guys to quickly comment it if you guys have found the issue. Okay, so the issue is that I'm getting the values only for my blue bars, okay, and not my orange bars. This is simply because I have asked my plot to be shown exactly after I call this particular syntax. Okay, so it's not considering my orange bars. Now, if I call the plt.show function outside my loop, as you can see, I have the numbers for my orange as well as blue bars over here. Okay, so this makes reading the graph much more easier. Now, you can make it a common practice whenever you're plotting a graph. You can just simply follow this method so that you do not have to guess any sort of value and you have the accurate values with you while you're analyzing a graph. Okay. Another thing that I want to find out is the relationship between the salaries of the employees and their departments. Okay. Now, in order to do that, I am again going to use the count plot. I'm going to say sns.countplot and I'm going to have my data as df and my x-axis is going to represent my salaries and my hue is going to represent the departments. Okay. Now again, I'm going to simply say sns dot. Okay. Now I'm going to again rotate my x label text to 90 degrees so that it's more readable. Okay. So as you can see over here, I have low. Okay, so my x-axis should have been my department. Okay, and my hue is going to be my salary because I have only three different types of salaries, that is low, medium, and high. Okay, so this makes more sense. So I have the sales department where a lot of employees have lower salary, a little less than them have medium, and very few of the people in sales department, so basically the VPs or the managers, people of that position have extremely high salaries in sales department. Whereas accounting, the ratio is pretty fine. I mean, more than 200 have low and a little less than them have medium. And again, very few of them have high salaries. Same for HR department. Technical department, again, a lot of people have low salaries. Okay. So if we see the most ideal department over here is management, almost equal number of employees have low, medium, and high salaries, right? No wonder people from the sales and accounting and technical department are leaving the company more often because most of the employees have very low salary, right? As you can see in this graph. So as I saw earlier that a lot of people from the sales, accounting and technical department were leaving the company. And I can also see that these three departments have the maximum number of employees who are getting very low salaries. So I'm going to quickly see the relation between salaries and the people who are leaving the company or not. Okay, so the next thing that I'm going to analyze is, do salaries affect the employees leaving the company? Okay, so in order to do that, I am again going to plot a count plot saying sns.count plot, and my data is going to be df. My x-axis is going to contain the salary, and I'm going to separate it by hue left. Me print it. So there. Now I would like to see the exact counts on these bars. So I'm going to follow the same method. I hope I don't have to explain it to you guys. You already understood how you guys can get the counts displayed on the bars. Okay, so I'm again looping through my containers and I'm simply printing. And as you can see over here, people with low salaries, 1,000 of them left, more than 1,000. With medium salary, around 700, which is still fine. People with high salaries, very less people left, right? As you can see, only 48 people left who are getting high salaries. So salaries do play a very crucial role in retaining the employees in the company. That's something we can clearly see through this graph. Okay. So if I were to calculate the percentage of people who left and who were getting low salaries, I would simply say 1174 divide by 4566. Okay, and I would multiply it by 100. So 25% of the people who are getting low salaries left the company, whereas people with high salaries, I would simply have to say 48 divide by 942, and I would multiply it by 100 and I would simply print it. So only 5% of people who are getting higher salaries left the company. If I were to do it similarly for medium salaries, okay, so 17% of the employees who were getting medium salary left the company. So again, the percentage is highest for people who are getting very low salaries, right? All right, so moving on to the last question for this particular section of our video. Does the work accidents affect employees leaving the company? Okay. So again, I'm going to do a count plot for this question. I'm going to say sns.count plot. I'm going to pass my data equal to df, which is the variable that's storing the data. And my x variable is going to be work accident, and my hue is going to be left. And if I go ahead and plot the graph, okay, so as you can see in this graph, 0 represents the employees that did not have any work accident, and 1 represents the employees that did have work accidents. And as you can see, a lot of people left even though they did not have any sort of work accidents in the office, right? But comparatively lesser people left who had conflicts in the work environment, right? So if we were to calculate the percentage, I would simply have to follow the same method to get the labels for my bars, and then I would loop through it, print it. Okay, so now if I were to calculate work conflict percentages, I mean people who had work conflicts and left. So if I were to calculate that, 105 divided by 1745. So as you can see, 6% of people who did have work conflicts in the office left the company. Whereas if I were to calculate no work conflicts, so 22% of the people who had zero work conflicts in the office left the company. So we can conclude that work conflicts do not really have any sort of impact with people leaving the company. So this was the last question for this particular section. And I'm sure you guys can go ahead and explore the data set even further. You guys can go ahead and explore different relationships between different columns, different features that we have, right? And you can maybe come up with better conclusions that we did in the video. But this is how a basic EDA is performed on a data set, where you try to answer different questions, you try to ask the different questions through a data set and come up with insights. Right? So this was it for this section.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with iHub IIT Roorkee. Through this course, you'll get to learn data analytics from industry experts and IIT faculty in depth. You'll learn tools like Excel, SQL, Power BI, Python, and K9. This data analytics course is praised by our learners, and their user testimonials are available on our Intellipaat Achievers channel. You can check them out. The link is available in the description below. So, if you are really interested in learning data analytics, this is your opportunity. Click on that Apply Now button right away and get started in your data analytics career journey.